Hello? Audible? Okay. So should I start from the beginning? Okay, so we have a list of poster presentation with us. The first poster presentation is by Naga Raghuram. Is Naga Raghuram here? Okay. The recorded video of Naga Raghuram will be played in a while. We'll have a 3 minutes poster presentation, and after that 1 minute of question answer. So we can start with Naga Raghuram.
Good afternoon everyone, my name is Raghuram and today I am going to give presentation on double node upset tolerant or HBD15TS RAM cell design. Actually, static random access memory cells are important building block for digital circuits like HBD15TS RAM cell design. Processors, SOCs, static random access memory cells are important building block of digital circuits like modern embedded systems. Processors, SRAMs are SOCs, static random access memory cells are important building block of digital circuits like modern embedded systems. Processors, SRAMs are SOCs, static random access memory cells are important reliability of digital circuits like modern embedded systems. Processors, SRAMs are SOCs, static random access memory cells are important reliability of digital circuits like international technology roadmap ITRs are important reliability of digital circuits like
Sorry for the inconvenience. It seems the video is too big. Okay, so on the list, the second is Kamal Shrivas. So is Kamal Shrivas in here? Okay, Kamal Shrivas, are you interested in sharing your video? Hello, it seems you are present. Unmute कर सकते हैं इनको? Can you please unmute Kamal Shrivas? Okay, you can write in the chat box if you are available. Okay, no issues. So we'll play the video from Kamal Shrivas. Yes, ma'am. Okay. Hello. Are you interested in playing your video yourself? Hello, Kamal. Can you ping yes, please? Okay, no issues, Kamal. We'll present the video by Isaac. Okay.
Yes, sir.
So.
Hello everyone, my name is Kamal Srivas. I am pursuing AMTRAC from Triple ITM Gwalior in Belays and Embedded System. The title of the paper is Low Noise Amplifier for
Hello, ma'am.
Monitoring System.
Hello.
AMTRAC from Triple ITM Gwalior in Belays and Embedded System. The title of the paper is Low Noise Amplifier for Monitoring System.
Hello.
Yes, Kamal.
Triple ITM Gwalior.
In the video, there is some problem. The screen sharing is not visible. So please you share my poster and then play the my video.
Okay, sure.
Thank you, ma'am.
Differential input technique with large transistor is used to reduce the input ripple noise. Class AB technique is used at the output state to increase the voltage swing and enhance the GM by leaf efficiency. Input ripple introduction class AB technique is used operation amplifier are the versatile device used essentially and enhance the variety of high frequency analog machine system. The application amplifiers are the versatile device requirement of electron industry variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement special system design, variety of signal processing, special function, the analog instrumentation, analog computation, requirement.
Hello, Kamal. Am I audible to you?
Yes,
Hello.
ma'am.
Okay, so is the video same that you have shared? Like the echo sound is there with the video.
Yes, ma'am.
Okay, so is this a
Hello.
problem with your side?
Can you present Simran? You can share the screen and yeah, if he is available online, so he can present right now as well.
Yeah, Kamal. If you have the video with yourself, you can present it. Is it
Yeah, ma'am.
possible?
Yes,
Yeah,
ma'am.
sure. Then you can present.
Ma'am, please share my poster and then I explain the all the part.
Like two people cannot share at the same time. That
No,
is the
ma'am.
issue.
Only you share the screen. I'm only explain.
Okay, okay. So we'll be sharing your poster and you'll explain. Okay.
Yes, ma'am.
Okay.
Yeah. Okay, ma'am. Hello, everyone. My name is Kamal Srivat. The paper title is Low Noise Amplifier for Health Monitoring System. The abstract of the paper. This paper presents Srivat. The paper title is Low Noise Amplifier for Health Monitoring System. Ma'am, this paper, the voice is repeating. The paper title is Low Noise Amplifier for Health Monitoring System. This paper, the voice is repeating. The paper title is Low Noise Amplifier for Health Monitoring System. This paper, the voice is repeating. The paper title is Low Noise Amplifier for Health Monitoring System. This paper, the voice is repeating.
Yeah, there is some issue with our side. We'll be checking in a while. Can you wait for 2 minutes, please?
This paper, the voice is repeating.
There is some issue with our side. Will you please wait for 2 minutes? Will you please check, Kamal, will you please check this?
Okay, hello.
Yeah, it seems it's fine. So you can start.
Okay, ma'am. Hello, everyone. My name is Kamal Srivat. I am from Triple ITM Gwalior. I'm pursuing MTech in BLS and Embedded System. The paper title is Low Noise Amplifier for Health Monitoring System. This paper presents a low noise, low power approach amplifier circuit to amplify biomedical signal at low frequency. Complementary based differential input technique with large transistor is used to reduce the input refer noise. Class AB technique at the output stage to use to increase the output swing and the power consumption. The introduction operands and amplifier are by versatile device and the important block of the analog and mixed signal design. The application of the op-amp is in the special transfer function used in signal processing and biomedical device. In this paper, we are using differential amplifier and the two-tail current technique, and the output state class AB amplifier will use to reduce the power consumption and increase the GM by ID efficiency. The operation and the methodology of the uh, proposed amplifier is like this. So in the figure, the M2, M3, and M4 and M5 is used for the drive the input signal, and the transistor M1 operates as a constant current source. This constant current source act as an input signal. M2 and M3 transistor, and the M6 is used as input signal for M4 and M5 transistor. M2 and M4 is used as a non-inverting input, and M3 and M5 is used as a inverting input. Uh, and the current mirror is used to provide the same amount of current to control circuitry, and the two transistor is used as a current sink, and there is the two transistor is used for in using the output stage. There is the some output result in the this is simulating at cadence 180 nanometer SCL PDK. And the output capacitance is 25 picofarad, and we found the 76-degree phase margin, and 90 dB gain margin. Supply voltage is 0.18 millivolt, and power dissipation at 22.34 microwatt, and slew rate is the 9.42 megahertz, and CMR and dB 97.1, and noise is the 13, and ICMR is the 1.4. Conclusion: using the proposed technique for implementation of low noise amplifier, it is found that the proposed circuit reduced the input refer noise of the amplifier by 44.44. And thank you.
Hello, Kamal, is I audible?
Yes, sir.
Yeah, just you said the supply voltage is 1.8 millivolt. Is it
No, ma'am. No, sir. 0.18.
0.18 what volt?
Yes, sir. Millivolts.
0.18 millivolt supply you used.
Yeah, simply sir 1.8 volts sir.
1.8 what volt millivolt?
Volt sir.
Okay, which technology you used?
Sir 0.18 nanometer.
Okay, so can you explain just that what is gain for amplifier?
Sir, output voltage upon input voltage sir.
And which are the parameter that has to be fixed for low noise amplifier? I mean analog parameter.
Sorry sir, I don't know.
Okay, for 180 nanometer, which foundry you used? TSMC, UMC, or somewhat else?
Sir, SCL prime.
Okay, and which tool you used for simulation?
Cadence sir.
Okay, then how you have evaluated slew rate?
What sir?
Slew rate, how you have evaluated?
Sir, I have found output current and output capacitance.
Okay, yeah, last question. What is slew rate?
Uh, the slew rate is defined as the how much speed the output is changed according to the input signal.
Sorry, can you repeat the same?
So इनपुट सिग्नल के अकॉर्डिंग सर हमारा आउटपुट कितनी स्पीड से मतलब चेंज हो रहा है सर.
Okay, okay, fine. Thanks, Pramod.
Thank you sir.
Any more questions from the audience? Okay, so let's try with the, thank you so much, Kamal, for presenting. So the first student, we will present the video for the first student also, Naga Raghuram.
Or HBD15T SRAM cell design. Actually, static random access memory cells are an important building block for digital circuits like processors, SOCs, microcontrollers, FPGAs, etc. So, reliability of this SRAM is a paramount for modern embedded systems. SRAMs are sensitive to ionized radiation
Hello.
particle streams. An error in a SRAM could lead to system malfunction. The first recorded satellite failure resulting from radiation was the Tesla in 1962. Even International Technology Roadmap for Semiconductors (ITRS) 2015 planned the control of soft errors in SRAM in its near-term goal 2015 to 22. So, examples: satellites must not fail as repair interventions are impossible to be carried out. The safety of electronic systems in avionics is of utmost importance and must be ensured in spite of high altitude radiation levels. Even planes, cars, trains and communication systems integrate a constantly increasing number of electronic components, increasingly complex, where even relatively low radiation levels can lead to important risks. And the operation and safety systems at accelerators require a high mean time between failures for reaching ultimate design goals and achieving scientific breakthroughs. Even medical equipment like pacemakers, which were implanted in the body, must work even in the radiation environments. So, in this regard, the SRAM, which is considered as the basic element for an embedded system, which is very much prone to ionized radiations, uh, it must be robust in radiation environments. So, as mass devices are shrinking to nanometer dimensions and an increase in circuit density results in an upsurge in the susceptibility of VLSI circuits at terrestrial level. Hence, This issue is fetching the attention of researchers. Terrestrials of terrors occur due to radiation strike of alpha particles from IC packaging, electromagnetic interference, and radiotherapies, etc. These effects in turn require radiation hardened by design circuits. While designing a circuit for a high radiative environments, there is a trade-off. There will be a trade speed and production cost. Circuit level principles like gate sharing and dual modular redundancy can drastically reduce soft error rate, okay, due to rapid scaling of device dimensions and hence the increase of device density. The transistors are placed close to each other such that ionized particle strike at a device breaches into the adjacent device, resulting in an upset at the neighboring node. This event is addressed as single event double node upset. So the actual radiation particle strike at a memory cell may directly lead to a single event upset. So for a soft error to occur at a specific node in a circuit, the collected charge Q at that particular node must be more than Q critical. So radiation hardening is a process of making electronic components and circuits resistant to damage or malfunction caused by high level of ionizing radiations. Thereafter, we have proposed an RHBD15T radiation hardened by design 15 transistor SRAM cell, which is having an isolated read and write paths. We use a PMOS for read and write operations. Nodes Q, Qn, S0, S1 of the proposed SRAM cell are surrounded by PMOS diffusions only, as well as the has clearly shown that the particle strike at the different nodes, even though radiation particle strikes high radiation radiation particle strikes at different nodes are imposed, the data in the SRAM cell is successfully retained, and the layout of the SRAM cell has been designed by carefully maintaining a distance between sensitive nodes X, Y and WZ. The layout is designed with a keeping minimum distance from these sensitive nodes as 1.5 micrometer. Even write static noise margin and read static noise margin yields were calculated, and a Monte Carlo simulation with process variations has carried out for this static noise margin, write and read static noise margins, and the Six Sigma yields have been calculated at different voltages and has been reported here. At the end, we can say that RHBD 15T SRAM, which is the proposed SRAM cell, is SU immune. That means single event upset will not occur, and on minimizing charge sharing, that is by proper design of layout, it could also be an SEDU immune, that is single event double node upset immune also, and so multi-bit upsets will not occur in the RHBD SRAM cell, as well as the 4-way bit interleaved ECC 60 SRAM system has also been reported, and it is used to benchmark the proposed RHBD SRAM 4-byte RHBD SRAM system. So the 4-way bit interleaved ECC 60 SRAM system has a 2.14 times higher read delay than the 4-byte RHBD 1560 system, as well as 3.87 times higher write delay than the proposed RHBD 15T SRAM cells 4-byte system, as well as the 4-way bit interleaved ECC 60 SRAM system has a 3.5 times higher area when compared to the RHBD 15T SRAM cell 4-byte system. Thank you, Claire. Thank you everyone for this opportunity. Thank you.
Okay, thank you, Naga Raghuram. So is there any question from the audience?
Hello, Naga. Is I audible?
Yes, sir.
Yeah, the question is that in the last sentence you said the area for 60 SRAM is around 3 point somewhat time of your 15 T SRAM. How it possible? Like in 60 only 6 transistors are there, and in 15T 15. So Of course, your proposed cell has to be a more area in comparison with 60. But you said your one is more area efficient. How?
Sir, hello, sir. Sir, actually, I have built an ECC 60 SRAM system. That is a Hamming code based four-way bit interleaved 60 SRAM system. The comparison of those systems were the area of the SRAM system, 4-byte SRAM system, which is four-way bit interleaved and error correction coded system. That system area is greater than the 15T 4-byte system, which is not ECC encoded. Not 60 SRAM area, sir. It is a system area is greater since we have done four-way bit interleaving. So all bit sense amplifiers as well as bit lines we will need in 4 times for the implementation of the same. That's why the area of 60 SRAM system, which is error corrected coded and four-way bit interleaved, that area of that system is greater than the 4-byte system of RHBD 15T SRAM cell.
Oh, okay. Can you tell me like where the radiation hardened problem comes mostly?
Sir, in space applications, it will be occurring more in particularly in electronics, in ICs, the reverse biased PN junctions are more prone to this, are more sensitive to this ionized strikes.
Can you tell me the height above than that we are facing the radiation hardened issue?
Sorry, sir, I'm not altitude wise. I haven't seen at what.
Okay.
At what
And in the layout, have you observed any difference between the normal layout design techniques and the radiation hardened IC design techniques, or you just follow the same step as like the usual layout design?
I have followed the same rules, sir, but I have identified some sensitive nodes between which I have maintained a distance of 1.5 micrometer minimum distance, so that charge sharing will be avoided between the sensitive node pairs.
Yeah, but if you might have seen like in radiation hardened, there should be a round layout design technique. Might you
Yes,
have
sir.
seen?
God rings.
It
God
is
rings
not
will be used.
similar to the normal design technique, is it?
Right, sir. God ring technique is a layout technique, which will be followed in radiation hardened by design. But in this particular design, I haven't followed that
So
layout.
even how you have been compared your data with the state of the art radiation hardened cells, because of course only these techniques gives the better results, because normal technique can't perform better.
Right, you are very true, sir. I have compared in terms of simulation, that is pre-layout simulations only. I have compared. My results were shown, which are of pre-layout simulation results, sir.
Okay, and for radiation hardened, how you have built the environment during the simulation, like how the environmental condition you have tested for your cell?
Sir, for to replicate an ionized particle strike on the reverse biased junction, the mathematical model of that is a double exponential pulse. So we can so the double exponential pulse has been a current pulse has been introduced at an reverse biased junctions and tested whether the data has been retaining or not in an SRAM cell. Likewise, I have created a radiation strike at a SRAM cells or different nodes of the SRAM cell.
Okay. Thanks, Naga.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you for the presentation. So the next attendee with us is going to present live Jogesh Kumar.
Good afternoon, everyone. Good afternoon, everyone. My name is Jogesh Kumar. And I am from IIT Indore. My topic is about semi-autonomous drones for terrain monitoring and identification of terrain modifying actors. With me, Gopal Raut and Santosh Kumar Vishwakarma sir have been part of this research project. Going into this, nowadays like deforestation is happening a lot everywhere, and like it is a critical issue because this leads to less oxygen level, and also forest conservation is very important for wild animals. And also like now many NGOs have kept some programs to bring awareness about deforestation. So for this, a human cannot be in a forest and survive, do a surveillance all the time. So for this thing, we need some drones, which can do this continuous monitoring. Based on this idea, we have made a drone which is semi-autonomous, which can do the surveillance using some functionalities. So the methodology which we have used in this is like our drone which we have made has the autonomous flight control. Means like it can operate in two modes. One is autonomous mode and as well as manual mode. Manual mode is nothing but like you can see here a trans receiver, and a control is there where the manual mode is operated using that, so that the user at the ground station can operate the drone, and whenever we want to take it to autonomous mode, a signal can be sent from the ground station so that it can operate in the autonomous mode. And if there is some default during the autonomous mode, then it will get back to the manual mode, and every operation will be in our hand. So this is the autonomous flight control which we have designed in this drone. And the speciality about the drone is we are using the Indian processor, Swadeshi microprocessor. This is Vega AS1061. Nowadays, like many drones were there, and they are using some ARM processors, which are the foreign based. There is no drone with Indian processor. So this is the drone made of Indian processor, which is cost effective as well, and the security will be more for this drone, as everything is done from the scratch. And the second feature in the drone is day and night vision using image processing. So in the daytime and as well as nighttime, the drone can do this continuous surveillance in the forest area. So during night time, like there are some night vision cameras which is available in the Indian market at low cost. So we are using that, and along with the camera modules, we are also using the thermal sensor. So if the hardware is heated up or some forest is burning up, then some signal will be sent to the ground station. So we will be aware about the forest, and the forest officers can take an immediate action upon that. And the communication to the ground station is done using LoRa. The two-way data link is established between the drone and the ground station. So there will be one R-type based RF module on the drone as well as on the ground station. So the information will be sent between them, and the communication will be happening. So every update will be on the ground station. And the fourth functionality in the drone is object recognition and tracking. We have used some filters in this for recognizing the objects and tracking the path. So the parts what we have used in the project is the microcontroller, the Indian based, and also temperature sensors, wind sensor, GPS module, gyro and accelerometers, LoRa camera modules, and photo diode pair. Uh, Generally, the conventional drones are not handling the failure, and hence they are not reliable in the terrain-based regions. So the proposed device will be reliable in terms of fault handling for the propeller failure as well as the wheel failure. The drone will support the satellite communication through which it is capable of communicating and controlling for long distance. The device will monitor all the activity related terrain monitoring and identification of terrain modifying actors that contain tree cut marks, wood cutting. So if some tree is cut, it can be identified using the drone. Yeah, this is overall view of the drone made by us. So there are four functionalities which have explained. in the future, like we are thinking to use the solar panels, because we are using the batteries, so the battery needs to be regularly charged. But if the drone is somewhere in the middle of the forest, we can't send our batteries there. So the novelty which we can bring in the future is using the solar panels to use the solar energy and generate the power, and also wind dynamo which can utilize the wind power when the drone is operating. So there are also some optimizations which we are looking in the drone. Yeah, thank you. And also I request to play one video of our drone. We would like to thank Mighty and IIT Indore for providing the required hardware, CDAC for the invaluable guidance and time, and also we also thank the Maker Village for the support during this project. Thank you so much.
Thank you, Jogesh. So is there any question from the audience?
No, it's from CDAC team, Vega processor. Yeah. 64. There are 64. You mean? In Linux, we have programmed in RAM, like the board. Thank you.
Thank you, Jogesh. So the next, for the next candidate, we have Puran Singh. So it seems Puran Singh is present. So are you interested in presenting your poster? Hello. Yes, Mr. Puran, you can unmute yourself. So are you interested in presenting your poster? Hello? Am I audible to you? Hello? Okay, so from now onwards, whoever is attending online, we'll play 3 minutes of the video so that we'll, as we have time constraint, so we can share the video of Puran Singh.
Hello,
Yes.
am I audible?
Yes.
Yes. Yes, ma'am. Please share our uh, poster.
So would you please try to end this in 3 minutes, within 3 minutes?
Yes, ma'am. Yes, ma'am. Sure, ma'am.
Okay.
So, good afternoon, everyone. I'm Kunal Jadhav from Mahindra University. I am presenting Smart Farming Architecture with Water Management System. Our goal was to develop sustainable solutions for reducing the amount of water used in the farming. Our motivation led us to the challenge of determining exact moisture content of the field in agriculture. In India, there is a wide range of farmland in terms of size, type of soil, and climate. Sensors that are commercially available are not ideally suited for calculating the moisture value, as we will encounter issues like sensor placement, management zones, and power consumption. To solve this problem, we have came up with the rail bus architecture. In this, rail is the replication of upside down monorail, and bus is the box that will travel on the rail and map throughout the farming field. This bus will have a robotic arm or servomotor implementation, which will insert the sensors into the soil and capture the moisture and temperature values using resistive moisture sensor, capacitive moisture sensor, and temperature sensor for soil. To reduce the complexity of using batteries, we have designed PCB, which will take 230-volt AC input and convert that to 5-volt DC voltage in order to control the sensors via a development board called ESP32. After sensing these values via cloud like ThinkSpeak or AWS, we can send this data to the cloud for further computation and data collection for the future. With the infrastructure, data collection, data management, and automated irrigation are completed in an intelligent manner, as name implies. Our future goal is to develop machine learning based model, which will give the exact value of moisture using parameters like moisture values coming from both type of sensors, distance between the crops, type of soil, soil temperature, and climate temperature. Our model is more efficient and effective in indoor farming, and we believe that with this, we can help farmers tremendously to reduce the amount of water they are using on day-to-day life. I'm open for questions now.
Hello, Kunal.
Yes, sir.
Yeah. So here, which ML model you use for the data classification?
We are basically the machine learning model which we are thinking to use. As I said, it is a future thinking. So we are thinking to use multi-variable regression model because we have multiple parameters and multiple sensing values coming from two types of moisture sensors. Then we have seen that in India, the problem of management zones is huge. So the parameters which actually matters to management zones are temperature, then wind direction. By considering all these parameters which might affect the moisture value, we are thinking to come up with the actual machine learning algorithm. The idea of this poster was to have this bursary architecture, which will actually, take the values using these sensors from the soil in equal interval in equal distance, so that we don't need to, have multiple sensors buried into the soil throughout the field because that's not so suitable in Indian farming culture.
Okay. For the embedded system, which SoC you plan to use?
Which
SoC? I mean controller, microcontroller, which?
we have used ESP32, sir.
So how you may implement a ML model in that?
We are not implementing ML model directly into the development board, sir. So our
Okay.
idea is to via ESP32 we have Wi-Fi module on that. So we will send all this data to a cloud. We have implemented the same on ThinkSpeak. And on ThinkSpeak, we have this, as ThinkSpeak is being developed by MATLAB and all, they have this pre-coded toolbox for machine learning algorithms. So we will send all this information to the cloud, and on the cloud, we'll try to do the computation and we'll come up with the proper model or proper equation, which will try to find out the exact moisture using these parameters.
And if you don't have internet in farm, then?
So for the same, actually this particular part is the one of the part of our whole project. Our main idea is to smart farming infrastructure. So in my college, in Mahindra University, I have developed 4G or 5G IoT test bed. So basically, in this IoT test bed, we have developed the actual replication of 4G, 5G cellular network, and I have tested a robot on the same. So rather than using Wi-Fi or communication like LoRa or Leafy or whatnot, we can directly use cellular communication, and cellular communication is already established throughout the world. So the problems like coverage area and problems like speed won't be there when we are dealing with cellular network. So in from our college, we are going to have a research paper or patent on the same. So that's how we are thinking to deal with this problem, sir.
Nice. Thanks.
Yes, sir.
Kunal.
Yeah, thank you, sir.
Thank you, Kunal. Is there any question from the audience? No? Okay. Okay. Thank you, Kunal, for the presentation.
Yeah, thank you so much.
So the next presentation is by Megha Malhotra. So Megha, are you interested in explaining by yourself?
Yes, ma'am. Please play the poster.
Okay.
Good afternoon, everyone present here. My name is Megha Malhotra. I'm pursuing my M.Tech from SGS ITS Indore, Madhya Pradesh, in domain microelectronics and VLSI design. So coming to the exact portion, first, the title of my poster is Design and Analysis of CMOS Two-Stage Operational Amplifier using 180 nanometer technology. Coming to the abstract, this paper presents the design and analysis of two-stage op-amp using 180 nanometer technology. We have basically used the library UMC18. After the completion of a schematic view, the simulation is done through Credence Virtuoso tool. In this design, authors have used 1.8 power supply and frequency range lies in between 100 Hz to 100 MHz. And we have obtained the results in various parameters like 20 microampere bias current, aspect ratio W by L, input mode, common mode voltage, and the range is lying between 0.8 volts to 1.72 volts. The simulation results are reported in this paper and the design has been carried out in Kendall's Design Tools Lab. Now, coming to the introduction portion, we can see a block diagram of the operational amplifier, which includes differential transconductance stage, high gain stage, compensation circuitry, and bias circuitry. Generally, an operational amplifier is a three-terminal device, which consists of mainly an inverting input denoted by negative sign and the other non-inverting input denoted by positive sign in the symbol of op-amp. And both of these inputs are used at high impedance stage. Now, coming to the methodology portion, figure 1 shows the schematic view of a two-stage operational amplifier. The power supply, as I mentioned above, like the power supply of 1.8 was dual in this schematic design, and the common voltage range lies between 0.8 to 1.72 volts. Table 1, coming to the results section, shows the gain and phase degree values at various frequencies lying between 100 Hz to 100 MHz. And figure 3 depicts the frequency response showing gain and phase respectively at 100 Hz. The higher order gain value as depicted in figure 3 is 117.349 dB. And coming to figure 4, the lowest range of gain is 40.94 dB. And the corresponding phase difference is so. Concluding, so CMOS two-stage operational amplifier is simulated and analyzed with this 180 nanometer technology, and obtained results are as seen. Suitable efforts are made to improve the open loop gain phase margin for this technology. And the proposed CMOS two-stage op-amp is performing high gain and phase value, which is suitable for switch capacitor filters, A to D converter, and instrumentation amplifier applications. Thank you.
Hello, Megha.
Yes, sir.
Yeah. So, which are those two stages in this amplifier?
So one is the differential stage,
Mhm.
and second one is the common mode stage.
What is the use of common mode stage in this?
So by using the common mode stage, we have set particular we have set some voltage ranges. In between those voltage ranges, all the parameters are operating in the desired region of operation. And then for different values of those voltage, we have measured the gain and frequency respectively.
And in figure 1, you have shown the schematic. Is it for two stage or only for differential amplifier?
That's two stage.
So both two stages are there in this schematic, is it?
Yes, sir.
I think it is only differential amplifier. Okay, fine, thanks.
Sorry for one question. May I ask?
Yes, sir.
So you implemented using which tool schematic? Can you show again, please?
The Cadence Virtuoso tool and simulation I have done in Spectre.
Okay, so under which technology? In 90, 180,
So,
what you are?
yes, sir. 180 nanometer technology, and the library used is UMC 180.
Okay, okay. So what's the results that you have gotten here?
So we have depicted a particular range of gain and phase margin, phase degrees, in between the frequency range 100 Hz and 200 megahertz.
So other results also you can extract it, no?
Yes, sir. We can get.
Okay. Any more questions from the audience or from the attendees? Okay. Thank you, Megha. Thank you for this presentation. So the next candidate with us is Darshan Sarodip. So we are sharing the poster. So Darshan, if you are, am I audible to you? You are there?
Ma'am, I will share my poster.
Okay, that's fine then.
Yes, ma'am. Is it visible, ma'am?
Yes, it's coming. Yes, you can make full screen.
Okay, I'm trying. Where is it?
There is some pop-up coming in the right of the screen.
Yeah. Okay.
Oh yeah, that's fine.
Okay.
Yeah, you can start.
Okay. So, good afternoon, everybody. I am Darshan Sarode, MTech scholar, VLSI design from VIT Bhopal. Our topic is analysis of H-drain based cylindrical gate all-around tunnel FET based SRAM cell design. As we know, in conventional transistors, during scaling, we face short channel effects, which reflects to high leakage current and high dynamic power dissipation. To mitigate these effects, tunnel FETs were used, but they too have some limitations like its ambipolar behavior and less on current. So we used H-drain cylindrical gate all-around TFET approach over cylindrical gate all-around because of its better subthreshold swing and low leakage current. The primary motivation behind designing this system is to design a low-power SRAM cell to do a thermal stability analysis and to reduce on-chip size and to design more reliable circuit. We have used device to circuit application using lookup table model based approach. We will compile all the parameters in the form of lookup table then prepare a Verilog code for incorporating all the parameters in form of code, then write SPICE netlist based on circuit application, and then extract circuit level simulation using Synopsys tool. We have implemented SRAM cell in circuit simulation tool and will implement this circuit in HSPICE tool as well. Primarily, we will verify the hold, read, and write operations of a memory cell and then analyze the negative bias temperature instability and positive bias temperature instability effects. The expected outcomes will be it will be a low area circuit with better sub-threshold swing, low leakage current, and reduced effects of parasitic capacitances. The typical applications of these systems are to design a reliable system on chip, field programmable gate arrays, and IoT applications. We would like to thank IIT Indore, MPCST, and VIT Bhopal to provide this platform. Thank you.
Oh, thank you. Thank you, Darshan.
Yes,
Any questions?
Hello.
yes, sir.
Darshan, the waveform you have been shown. So which tool you use for the same?
Yes, sir. So,
Waveform you have shown.
yes, sir. This is the primary approach. So we have used the open source tool right now, LT Spice, and we will implement this in HSpice. That is the
Okay.
future approach, sir.
Okay, so how you choose the technology for implementation?
So it is a
Like
20.
at what technology the device has to be evaluated?
So this device is a 25 nanometer technology.
And the library file, how you chosen? Like how you come to know the like output use whatever you observed that is on like 25 means I mean you have designed yourself 25 nanometer or any foundry you use for the simulation?
Sir, actually this device has been is in the simulation mode. So it was designed using a TCAD model. So it is not fabricated yet.
Okay. Thanks, Darshan.
Yes, thank you, sir.
Thank you, Darshan. So the next candidate for today is Praful. So Praful, we are sharing your poster. Will you please explain?
Yes, ma'am. I'm sharing.
Yeah. Okay.
Ma'am, is it visible?
Yes.
Good afternoon, everyone. Present here, I am Praful Git, MTech scholar, VLSI design from VIT Bhopal University. Our topic is various leakage power reduction techniques in nanometer design. Power dissipation is a major issue in today's VLSI technology. Earlier, power consumption was secondary concern. The motivation behind this technique is in nanometer technology, power has become the important issue because increasing transistor count, higher speed of operation causes greater leakage currents. With shrinking transistor size and technology, reducing power dissipation and overall power management on chip are the key challenges. Because most of the electronic devices are battery operated, total power dissipated is dynamic power. It is caused by leakage current while the gates or device are in off state. Dynamic power, it is primarily caused by the circuit in active state. Leakage power increases at a faster rate than dynamic power in nanometer technology generation. Various leakage power reduction techniques are LECTAR, which is leakage control transistor, on-off logic, LC-PMOS, which is leakage controlled PMOS, transistor stacking. This system comprises of analysis and comparison of conventional CMOS inverter with LECTAR-based CMOS inverter for 45 nanometer technology. Our objective is to reduce leakage power and do comparative analysis of various leakage power reduction techniques. Here, based on the circuit simulation result, it has been observed that LECTAR technique has better optimized result. By using this technique, we have reduced power dissipation approximately 3 times than the conventional CMOS. Expected outcomes for this work is low power circuit, reliability, leakage power reduction. Application of these techniques in lower technology node, we can replace some primitive models by the optimized modules using these techniques like in FPGA and in system on chip. So this is all about our topic. We would like to thanks to IIT Indore, MP, PSP and VIT Bhopal for providing us an opportunity. Thank you.
Praful.
Thank you, Praful. Yes, questions, please.
The both circuit you have shown here, normal CMOS circuit and the lector circuit. So in that one, if
Yes,
you
sir.
see on the top, I think this is PMOS, and the below one, this is NMOS, is it?
Yes,
For
sir.
lector.
Yes, sir, for lecture.
Yeah. So how you
Yes, sir.
choosing the W by L for both one? Is there any mathematical numerical derivation for the same, or randomly you have selected for better performance? I mean.
Selected to optimize, yes, sir, for better performance.
Yeah. So is there any numerical demonstration or the methodology you used for WL selection?
No, sir, primarily not numerical approach. Basically, by using the various WL, so I got to know that this is giving the better results.
Okay.
So that's why I selected.
Okay.
Yes.
Okay. Fine. Trial and error things you used for this. Fine. Good.
Yes, sir. Yes. Trial and error. Yes, sir. Thank you.
Thank you, Praful. So the next candidate for today is Vijay Pratap Sharma.
Yes,
So, okay. Are you sharing your poster?
no, ma'am, you share.
Okay. Okay. We'll be sharing your poster.
Okay.
Hello, Praful. Will you stop sharing your presentation? Hello, Praful. Am I audible to you? Okay.
Yes, ma'am.
So this is, oh, sorry. There's a mistake with our side. The next presentation from here. It's on the name Vijay Pratap Sharma.
Yes, ma'am. Ma'am, please share the slide or
Yeah, it's taking some time.
okay, ma'am.
Meanwhile, if it is ready with your side, okay, it's coming. Oh, yes.
Good
Yes, you
afternoon,
can start.
everyone. Good afternoon, everyone. I am Vijay Pratap Sharma from Oriental University, Indore, Madhya Pradesh. I am presenting poster on the topic of analysis and implementation of MAC unit for different bit precision. In this poster, I designed MAC unit and compare all parameters for the 4-bit, 8-bit, 12-bit, and 16-bit. MAC is the basic unit which performs the operation of multiplication and addition both at the same time, and this MAC unit is designed on Vivado HLS tool and implemented gyro evaluation board. MAC used for fundamental arithmetic tasks. The MAC is essential block of several digital processing systems. That is the DSP system. For any DSP, we want that DSP has the low power and high speed, and it make possible by MAC unit. That's why it's play a vital role for the DSP system. In order to accomplish good performance in digital signal processing, high-speed MAC unit is necessary. Basic MAC operation makes up the convolutional layer, which takes up the majority execution time. MAC unit determines the power and speed of overall system. From the figure first, it is clear that the first step is multiplication of 2 bits, and after then addition performance will done, and after that accumulation, and then we get our results. Figure 2 shows that architecture which is automatically generated by the Xylin Vivado tools after inserting the code of MAC unit. Now comes at the table the resource utilization report. The resource utilization report shows that as the number of bit precision increases from 4 bit to 16 bits, physical parameters like logic slice, slice LUTs, slice registers, DSPs are also increased. And the second part, on-chip power report, which contains logic power, signal power, IO power, the number of bits precision increases, the parameter also increases. In the third part, delay report, as the number of bits increases from 4 bit to 12 bit, the parameters like path delay, logic delay, input delay, route delay have nearly same value, but for the 16 bit, it has have different value. Now there are some reference papers are included. Here in the first paper, G. Rawat and et al. Work on the Recon resource efficient Cordic based neuron architecture. In this paper, he also used the MAC unit for better performance of Recon architecture. And in the paper second, ASK Wamsi and S. Ramesh also designed the 16-bit efficient MAC unit by using Vedic mathematics. In paper third, M. Yuvraj et al. Designed the optimized MAC unit by using integrated Vedic multipliers. And there are 2 more papers I discussed. In this paper, the sigmoid activation function is used for smooth functioning, and deep neural nets as the method for the quantitative structure activity relationship discussed by the JAMA et al. Thank you.
Yeah. You've shown the comparison result only for LUTs. Have you observed for DSPs? Like how much power consumed if you use the DSP instead of LUTs?
No, sir, I am not using in that table, but I am doing from that side also.
Okay, fine. So is there any motivation? Only you have shown the results in regards to the LUT only?
Yes, sir, but I am not discuss more things.
Fine. Yeah.
Just take a review.
Mm-hmm. Yeah, thanks.
Thank you.
One more question by my side, Vijay. Am I audible to you?
Yes, ma'am. Yes, ma'am.
So, have you shared like which board you have used for FPGA implementation?
Jaiva board, ma'am.
Okay, so what's the bit precision for it? Like LUT.
Sorry?
What's the LUT bit precision? Like how many bit LUT is there in Zybo? Can you explain?
How many bits? 256, I think.
No, not the count of the LUT. The bit precision of LUT. Like how many bit LUT is there?
In Jaiva board?
In Zybo, yes. Like every FPGA has its own LUT and the bit present for its LUT is also defined. So can you tell me, like, do you have any idea of it?
Sorry, ma'am, but I'm
Okay, no issues.
sure.
Thank you, Vijay.
Thank you so
So
much.
the next student, yeah, no issues. Okay. So the next candidate is Ravindra Pandey. So, okay. Ravindra is here with us. Yes, Ravindra, you can join.
Can I speak in Hindi?
Good afternoon, everyone. This is Suraj Kumar Soni.
PDF नहीं से
Yes.
पूछता है
Good afternoon, everyone. This is Suraj Kumar Soni and my friend
Ravindra Pandey.
I am from AKS University. We going to present synthesis and characterization of nano size ZNS particle using different capping agent. हमने ZNS नैनो पार्टिकल को सिंथेसिस किया जिसमें डिफरेंट कैपिंग एजेंट का उपयोग किया लाइक PVA, MEA एंड PEG सिंथेसिस ZNS को सिंथेसिस करने के लिए हमने को प्रेसिपिटेशन मेथड का यूज किया फ्लो चार्ट हाउ टू मेक ZNS पाउडर जिंक एसीटेट को वाटर में डिसेबल घोल लिया और फिर कैपिंग एजेंट को का सॉल्यूशन अलग अलग
सबसे पहले हमने जिंक एस्टेट को पानी में डिसॉल्व किया और उसका सॉल्यूशन बनाया। उसका सॉल्यूशन बनाने के बाद हमने डिफरेंट कैपिंग एजेंट को पानी में डिसॉल्व किया और उसका भी सॉल्यूशन बना लिया। इन दोनों के सॉल्यूशन बनाने के बाद इन दोनों को आपस में मिक्स कर दिया। मिक्स करने के बाद हमने इसमें सोडियम सल्फाइड का एक सॉल्यूशन बनाया और सोडियम सल्फाइड के सॉल्यूशन में हमने इसे ड्रॉप बाय ड्रॉप मिलाया और उसके बाद हमें जो वो प्रेसिपिटेट प्राप्त हुआ उसे हमने फिल्टर पेपर की हेल्प से फिल्टर किया। उसके बाद हमने इसे उसके बाद हमने इसे 150 डिग्री सेल्सियस पर ड्राई किया। ड्राई करने के बाद हमने इसे ग्राइंड कर लिया और जो हमें पाउडर मिला उस पाउडर की कैरेक्टरिस्टिक्स को देखने के लिए हमने निम्न टेक्निक्स का यूज किया, जिनमें से एक है XRD, दूसरी है सेम, तीसरी है UV विजुअल और चौथी है OM ऑप्टिकल माइक्रोस्कोपी। सबसे पहले हमने XRD किया। इसके लिए हमने मेनली XRD में हमने डिफरेंट कैपिंग एजेंट के ये XRD लिया, जिसमें ग्राफ में हमें साफ साफ दिखाई दे रहा है कि जैसे जैसे हम उसमें कैपिंग एजेंट मिलाते जाते हैं तो उनका जो पीक होता है, पीक की वैल्यू, पीक जो होता है, पीक की चौड़ाई बढ़ती जाती है, जिससे हमें ये पता चलता है कि जैसे जैसे उसमें कैपिंग एजेंट हम मिला रहे हैं तो उसमें पीक की वैल्यू इंक्रीज हो, पीक की जो साइज वो इंक्रीज हो रहा है, जिससे ये हमें पता चलता है कि नैनो पार्टिकल जो होता है उसका जो साइज छोटा होता जा रहा है। उसके बाद हमने जो इस डिफरेंट कैपिंग एजेंट मिलाने के बाद इसमें जो हमें 2 थीटा की वैल्यू मिली, जो कि उसके पीक की वैल्यू है वो 28.54 डिग्री, 47.62 डिग्री एंड 56.28 डिग्री मिला, जो कि लैटिस पैरामीटर से समानता रखता है। फिर इसके बाद हमने ये जो हमें डाटा है ये हमें JCPDS कार्ड नंबर 050566 से मिला है, जो कि एक इंटरनेशनल डाटा है। फिर इसके बाद हमें जो ये XRD में हमने जब डिफरेंट कैपिंग एजेंट को मिलाते हैं तो हमें जो डाटा प्राप्त होता है उसमें उसका वैल्यू हमने सरल फार्मूला 0.9 लैम्डा बाई बीटा cos थीटा होता है, वेयर बीटा इज डिनोटेड एज WH फुल विड्थ हाफ मैक्सिमा एंड lambda is denoted for wavelength and theta is diffraction angle. इसके बाद हमने ऑप्टिकल माइक्रोस्कोपी किया। इसके यूज से हमें ये पता चला कि जो हमने कैपिंग एजेंट मिलाने के बाद हमारा जो मटेरियल बना है वो कैसा है, उसकी साइज कैसी है, मतलब उसके पार्टिकल्स का साइज कैसा है, इसका पता चला। इसमें जब हम उसमें MEA मिलाते हैं तो उसका जो साइज है वो उसकी जो साइज की रेंज है वो 20 से 200 नैनोमीटर तक की होती है। उसके बाद जब हमने उसमें सेम किया तो सेम से हमें ये जानकारी मिली कि उसका जो पार्टिकल पी जब उसमें मिलाते हैं तो सेम में हमें ये नॉलेज मिला कि जिससे सेम करने के बाद पार्टिकल जिंक सल्फाइड में कैपिंग एजेंट मिलाने के बाद जो सोल्यूशन बनता है वो उसके जो पार्टिकल होते हैं वो होमोजीनियस होते हैं। फिर हमने एक बैंड गैप निकालने के लिए यूवी विजुअल किया, जिसमें हमने ये देखा कि जब हम डिफरेंट कैपिंग एजेंट का यूज करते हैं तो इसकी जो बैंड गैप ऊर्जा है वो इंक्रीज होती जाती है। इसका मतलब ये होता है कि ये सेमी कंडक्टर है। और जो इसकी बैंड गैप एनर्जी है वो 3.85 EV से 4.22 EV के बीच में मिलती है, जो कि एक सेमी कंडक्टर की बैंड गैप एनर्जी होती है। और बस एनी क्वेश्चन?
So can you please tell me what is the application? I mean, advantage क्या आपको मिला finally?
Okay sir.
What is the advantage of
Yes sir.
this solution?
यस सर, जैसा कि हम जानते हैं कि अभी पूरे विश्व में कोरोना की वजह से जो सेमीकंडक्टर का शॉर्टेज हुआ है, उसके शॉर्टेज के बाद जो अभी भारत में ही जो हमारे मोदी जी हैं, उन्होंने जो 76,000 करोड़ रुपए की जो एक इस स्कीम अभी लॉन्च किया है, उसी स्कीम के तहत हम इसका उपयोग जिंक सल्फाइड का उपयोग डिफरेंट कैपिंग एजेंट मिलाकर सेमी कंडक्टर डिवाइस बनाने के लिए कर सकते हैं, जिनका उपयोग हम चिप में कर सकते हैं, मोटर वाहन सब में कर सकते हैं।
तो चिप बनाने में यूज करने से क्या फायदा होगा, वही मैं पूछना चाह रहा हूँ। जो अभी जो बन रही है चिप ऑलरेडी और आपके मटेरियल से बनेगी, तो उसमें क्या फायदा होगा एज कम्पेयर टू द कन्वेंशनल?
यस सर। सर मेनली क्या होता है, जो हम अभी जो फिलहाल चिप बन रही है वो
यस प्लीज।
सॉरी।
हेलो।
यस सर। सर मेनली ये कॉस्ट इफेक्टिव होता है, ये दूसरे मटेरियल की तुलना में इससे जो हम सेमी कंडक्टर चिप बनाते हैं वो जल्दी बन जाता है और उसमें कॉस्ट भी कम लगता है। हेलो सर।
Okay, fine. Thanks.
Thank you so much, Ravindra. For the next candidate, we have Priyanka Shah. So the poster for Priyanka Shah is here. So Priyanka, will you explain the poster?
Ma'am, you kindly play my video.
Yeah, sure. So kindly be there for the questions.
Yeah, sure.
Yeah, okay.
my gratitude towards our Honorable Pro VC Sir, Dr. Dhruv Gai, VC Sir, Dr. Sunil Somani, and my guide, Dr. Tan. Thanks to the Madhya Pradesh Vigyan Sammelan 2021 and IIT Indore. Also, I pay my gratitude towards our Honorable Pro VC Sir, Dr. Dhruv Gai, VC Sir, Dr. Sunil Somani, and my guide, Dr. Tanmay Kasbe, for giving me opportunity where I can explore my research work. Myself, Priyanka Shah, Research Scholar, Department of Computer Science, Oriental University, Indore, Madhya Pradesh. My today's presentation topic is a review on specification valuation of broadcasting routing protocols in VANET. VANET, the Vehicular Ad hoc Network, as we all are familiar with this term, it aims to establish a better and a secure communication among vehicles, that is vehicle-to-vehicle intervehicular communication. Here the nodes in the network are deployed in an unattended environment, which are generally subjected to the different types of attacks, that is the false injection attack, or they are involved in the different activities like traffic congestion, where the attacker gets the chance to compromise with the sensor node or the end routers, which are used for forwarding the false report from source to sink. Also, some events like abusing events happen, which can generate the abusing report to destination, which are sent through the source. But to overcome all this issue, we are indulged with the broadcasting of routing protocols, that how efficiently and in a secured manner they transfer the data from source to destination. For this, we have applied a cryptographic approach where we have implemented an RSA security algorithm to achieve the quality of service and in order to enhance the better and the secured communication among the vehicles. For this, we have considered the different parameters like throughput, packet delivery ratio, packet collision, and energy consumption. Here, the base routing protocol, which was considered, is the ad hoc on-demand distance vector routing protocol. And here, generally, we have worked on the reliable source node, how the procedure generally takes place. What we have done, we have established a configuration setup, and we have loaded the variables at the run times where the packets are simulated during the simulation. Also, the topology matrix and the protocols are established here. Initially, the nodes are assigned to the load variables, and they are being simulated and modified the topology matrix, and this the plotting of graph occurs. Plotting of graph generally means where the different nodes are present, the clusters are formed, and the nodes are actually attacked by the which attacker, that is seen over here. Now, to generate a security using RSA cryptographic approach, we have used the following steps. That is, encryption process is done where the sending of message takes place. Here, the RSA, which includes both public and private key pair, and a public key which is known for exchanging the messages. We have used a 256 symmetric key which is generated by the vehicles, so that when the vehicle is sending message to RSU, then the messages are encrypted using the public key received, and from RSU, that is a roadside unit, they are encrypted by symmetric key which is sent back to the RSU. RSU decrypts the received public key as by its own private key. Then the decryption process occurs, that is the process of receiving message, and thus the secured communication is established between them. In my research work, I have worked on the reliable nodes, but the future work shall be considered for some non-reliable work also. Thank you.
Hello, Priyanka.
Yes, sir. Good afternoon.
How much bit precision encryption model you used for the
Uh,
presentation?
105 bits.
105 bits encryption model or quantization stages you are saying 105.
There 105 bits have been used, which are taken for both the reply and the request node. And actually, the total encryption process we have involved around for the asymmetric encryption system, we have used 256.
Twice.
Hello?
Yeah, in last
Yes,
5
sir.
seconds it was not audible. Fine.
Yes, sir.
So can you tell me the basic difference between the model you discuss and the AES algorithm?
Sir, actually, the model which I have applied here is the flow traffic model, or we can say that the mobility model. And in this model, so what we have done, we have involved many nodes in the form of clusters, where all the clusters are present in a scattered way. And when any attacker comes over it, that attacker nodes that particular node where the attacker attacks, that the value of that node is collected or it is noted down. And since we have applied the RSA algorithm, so our main aim is to establish the better and the secured communication. So when that node is particularly attacked, the we have drawn a table where that the particular cluster node is counted, and on which number of node it is used. So this is how we have just calculated our or we have conducted our simulation process, and my overall simulation process was conducted on MATLAB.
Okay.
And sir, while if we consider about AES, so sir, we have used both the keys for private and the public keys, which was one with the two keys have been used here.
Okay. Fine. Yeah. Thanks.
Thank you, sir.
Thank you, Priyanka.
Thank you, ma'am.
Any
Thank you
more
for
questions? Yeah. Thank you. Thank you.
Okay.
So the next attendee is Priyanka Sharma. So
Hello.
are you there, Priyanka Sharma? Yes.
Yes, ma'am. Please share
Will you
my
share your screen?
Please
Will you
share
share your poster?
Yes, you share.
Can you repeat? It was
Please
not
share
audible to
my
me.
poster.
Yeah, okay, it's there. It's there. Your presentation is there. You can start explaining. Sorry.
Okay, thank you. My name is Priyanka Sharma. I am the pursuing PhD from IETDAB in the under the guidance of Dr. Vaibhav Nima. So my topic of presentation is approximating image signal processor architecture using 6080 hybrid SRAM memory. We using the computing approximation in our design. We using this applied this approximation for image processing. Basically, the image processing have a lots of data. So if we reduce that data size, so we getting the power require the less power dissipation. So we adopting two approximation technique for this architecture. One is using JPG compression technique to reduce the our image data size, and the other technique uh, we use a hybrid SRAM memory. That hybrid means we use the combination of both the two type of memory cells. One is a conventional 60 and the other one is 80 memory. So by using first approximation, we use a JPG compression. The JPG compression we use a discrete cosine transformer, quantization, zigzag scan, and the entropy encoding. So by using this technique, we reduce our image size up to 70%. It depend on which type of compression ratio we want. So we also reduce our image, but I'm getting reduced our image from up to 70%. Next, we use a hybrid memory. We run the failure analysis for conventional 60. So at worst corner for there is a two failures. One is read failure and the one is a write failure. So in lower supply voltage, the write failure is not so much compared to read failure. Read failure is critical. So if we are done the 30,000 Monte Carlo simulation in the using HSpice. So we getting that the conventional 60 have a larger failure, approximately 10 to the power 10 minus 10 failure probability compared to 80 have only 10 to the power minus 1 probability. So there is a this conventional 60 have a larger amount of failure at lower supply voltage. I use 800 millivolt for that supply voltage. So the idea behind of that, we make a hybrid, and we also run some simulations that the image luminance data, the higher bit of image data are more sensitive for the MSBs are more sensitive for noise compared to LSBs. So idea is that we store the MSBs in are more stable 80 cells, and the rest of the LSB are stored in the conventional 60. So we're getting approximately 39.8 less power dissipation compared to conventional 60. If we operate a conventional 60 for same accuracy of image, so we're getting around 39 percentage power dissipation. In this result show there is a images there. If we store our image in a conventional 60, there is some information loss. There's a pixels breaking there. And the same if figure 4c, I will store the same image in our designing. So there is a we getting a power saver, and without any it's very small degradation in image, and it's not visible by human eyes. So basically we done the MATLAB simulation for the compression, that algorithm JPG compression. We also, if we controller is the communication of controller is only by the compressed image. So access time of control is also reduced, and the regenerate by image we using a JPG decompression, where we use inverse discrete cosine transform, inverse quantization, and inverse exact, and after we getting again convert our image to real size. Thank you. Hello.
Hello. Priyanka, can you explain what exactly approximation word works here? It's like
So,
memory is just the memory, but you said here approximate, where the approximation comes.
so we just reduce the power. So approximation, it means you change this. If you
Yeah, got the point. So here you are talking about the novel architecture of your processing element or your 60 SRAM.
I'm working on both. I also the JPG compression and decompression unit is different, and the one part of this is memory. So I'm working on both, but in designing, I designing the simulation JPG compression and the decompression unit is different. We're using MATLAB simulation, and take the data from that, and this designing of 1680 I done in the cadence in 45 nanometer GPD.
Okay, so how you have extracted that figure 4?
Yes, sir.
Figure 4, you have shown that Lena image.
Yeah,
So,
yes, sir.
so that is you have extracted from MATLAB.
So I yes, sir, I getting the from extract from MATLAB, but the data I'm taken from the failure probability that done in the cadence.
Okay. Okay, thanks. Yeah,
Thank you.
thanks.
Thank you, Priyanka. Any more questions? Okay. Thank you, Priyanka. So the next student, so the next candidate with us is Vadik Panchal. So Vadik is here with us. So okay, I'll request Vadik to start his presentation.
Thank you. Good morning, everyone. My name is Vadik Panchal. I'm pursuing BE in Electronics and Instrumentation from IIT DAV. This poster is regarding for my final year project. We have designed that automatic number plate recognition system, which is loosely based on that character recognition, alphanumerical recognition from the number plate. And the idea behind this project is to implement a hardware for this. So firstly, we targeted a hardware model that will be a parameter specific. We all know that the implementing a software based simulation and a computer vision tool or which has a floating point algorithms. Implementing a hardware for that is a difficult one. So we set a strict parameters and a strict environment for that. For studying that, firstly we came to across that for the Indian standard plates, we mostly know, we all know that the number plates are not printed or having a exact figure or edges for the letters or numbers. So they are embossed or backward embossed on a metal or an alloy of metal. So detection of that, applying a Sobel filter like a edge detection over that number plate recognition, it's pretty much difficult. So we prepared a reference model which is used as a template for recognizing characters and numbers from the system. So here, as seen in the poster from the result section, you will see like the number of templates O, C, W, and M. They are basically fonts from the previous model implementation has a basically fonts, loosely based fonts, but for we have done the work that extracting the fonts from the plates and preprocess that fonts to make the more reliable and efficient for detection of that Indian standard alphanumerical letters. We targeted the models on Simulink using the Vigyan VHDL so that we can implement that on a FPGA FPGA board. Firstly, using the Vigyan VHDL, we implemented edge detection and a Sobel filter and a medial filter for noise reduction. We came to across that using implementing that result on a real-time video, we required a lot of frame buffer to process the video at the on an average 640 pixels. So we are working on this project still now for preparing the video to pre-process the video to a smaller context, so that the frame buffer required will be the less. So the nominal FPGA board or a mid-range FPGA board can be used, which can be cost effective for implementing that model. Thank you. Any questions, sir?
Yeah. Hello, Vidik. Which data set you use for the training evaluation?
Sir, audible नहीं है.
Hello, is I'm audible? Vidik?
Sir, data set for what, sir?
I mean, if you have to recognize the numbers on the number plate, so
Yes, sir.
which data set you use for training or inference?
Sir, data set, firstly, that majorly we created the templates and for parameters like binarization of that image and calculating the distance from that of the camera from the plate, how much distance is nominal and horizontal. The image will be an horizontal one or a vertical one.
So you prepare data set by your own, or have you used any prepared data set available on the cloud?
No, sir, prepared by own. The template has been prepared by our own.
How much images you have been created for training?
So like 10 to 15 images, we worked on it strictly that specified parameters for 10 to 15 images. Roughly we have clicked 60 to 70 images, but the template we have created for each letter or a numerical will be is of 2 or 3 templates.
Okay, then how much accuracy you observe?
Sir, from out of 10, yes, sir. In daylight, out of 10, we are successfully detected in 6 to 7 because of the nominal chrome. Like in a vehicle nowadays, everyone using a chrome accessories, so which will impact a lot, but nominally 6 to 7, 60-70%. Sir.
Okay.
Yes, sir.
Thanks, Will.
You show
Thank you,
the
sir.
another tool of Simulink, so many tools. May I have one question, please? You
Yes,
show
sir.
now 2-3 tools different. So may I use all tools you have used here, or are you planning to use for future applications?
Yes, sir. Firstly, sir, as an initiative, we implemented that on a software model using computer vision toolbox, and then targeting FPGA or implementing on hardware. We first go through the Simulink model. On Simulink, we have only implemented the 2 filters, that edge detection and a noise reduction filter.
Also you show
We are implementing the. Yes, sir.
So
Sir, can you repeat the question? I can't.
Hello,
I can't
Ankur
hear.
sir. You are not audible by the way. Hello, Ankur sir.
Yes, sir.
Yeah, fine. Very.
Okay, sir. Thank you. Thank you, everyone.
Thank you, Vadik. Thank you for the presentation. So we have Anurag Sharma with us, who will present an offline, and rest all the posters will be continued. Okay. I'm sorry, we are running out of time, it seems, because the panel discussion and the subsequent sections will be start in 4:15. So we'll directly go with panel discussion. So after 5:30, rest all the posters will be continued. So we can have a 2-3 minutes of break, and then we'll be starting with 4:15 with the panel discussion. Hello, is Professor Anurag Srivastava here? Will you please type in the chat box? I repeat, Professor Anurag Srivastava. Okay, sir. So can we start, Anurag sir? Can we start with it?
Yeah, of course. Thank you so much. Yeah, thank you.
Yeah. Okay. Thank you to all the students for all the presentations. That was quite informative, and obviously everybody learned a lot from it. Obviously, after this panel discussion, we'll have the rest of the poster presentations. So moving to the next segment of the conference, we are delighted to have with us some eminent speakers for a panel discussion on challenge and opportunity in Fabless and Fab Semiconductor ecosystem in MP. As a moderator for this panel, we have with us Professor Anurag Srivastava from ABP IIITM Gwalior. Professor Anurag did his PhD from Barkatullah University, Bhopal, and postdoc fellowship from Uppsala University, Sweden. He has over 20 years of teaching and research experience in the area of applied sciences. For the panel discussion, we have with us Mr. Preet Yadav from NXP Semiconductors, Dr. Ashish Kumar from ST Microelectronics, Mr. Narendra Sen from Ragbank, Mr. Puneet Mittal from VLSI Expert, Dr. Jagopal Pandey from CSIR Siri Pilani, Dr. Anirban Sen Gupta from IIT Indore, Dr. Ambika Prasad Sah from IIT Jammu, Dr. Shailesh Chauhan from LUT Sweden, Mr. Deep Sengal from SCL India. Now, I would like to request Professor Anurag Srivastav to start with the panel discussion. Over to you, sir. Hello, am I audible? Professor Anurag Srivastav, sir.
Hello.
Yes, sir. You can start. You can start with the panel discussion. Hello.
Can you hear me? Hello.
Yes, sir. Yes, sir. Yes, sir.
Okay, good.
Yes, sir. Over to you.
Yes, thank you so much. Yeah. So thanks to the organizers and thanks to the speakers in the morning who have deliberated on various topics, especially the keynote speakers and one talk by the government of Madhya Pradesh, State Electronics Board. And welcome to the panelists of this special session, and where we are having about 4 industry participants and 2 people from the scientific laboratories from India, and there is there are 3 academicians, and it includes me as well. There are 4 academicians as well in this particular session. So welcome all the panelists, Preet ji, Ashish Kumar ji, Narendra Sen ji, and Puneet Mittal ji, Jai Gopal Pandey ji, Evan, Ambika ji, Shailesh, and Deep Saigal ji. So with some of you, we have interacted during the October meeting, if you remember. And
Yes, sir.
For a few people, we are interacting with the first time. So they basically, if you look to the agenda of this panel discussion is basically that if you look at the objective of this Madhya Pradesh Vigyan Sammelan and Expo 2021, the idea behind this conference was basically to have possible synergy between the industry and academia, and of course involving the government institutions, especially the government of Madhya Pradesh and the laboratories of the government of Madhya Pradesh as well as in India, so that we can think of developing a semiconductor manufacturing or display manufacturing VLSI kind of ecosystem in Madhya Pradesh. And we have deliberated during our pre-conference meeting in October, and especially we talked about many possibilities in academia, and devising the syllabus of the students who are enrolled in the MTech program in VLSI or electronics, or who are doing their BTech program in VLSI or electronics. So there are a number of discussions have been made during that meeting, and in today meeting. If you look back to the recent development of Government of India, where Cabinet has approved the program for development of semiconductors and display manufacturing ecosystem in India, and they have talked about more than $30 billion US dollar incentive to position our country as a global hub for electronics manufacturing with semiconductor as a fundamental building block. And out of this, they have also categorized that about more than $10 billion has been approved for the development of semiconductors and display manufacturing system in India. So in this context, keeping this one, because this is a recent development, around 15th or 14th of December only. So Madhya Pradesh government is also interested in investing in this particular sector. And I'm sure in the morning session when our Honorable Minister of Science and Technology, Sakleja was giving his talk, he has also talked about the possibility of some incentives from the government of Madhya Pradesh as well. And for that, we need to think of having a synergy between academia and and industry. And of course, those who are located in Madhya Pradesh or those who belong to Madhya Pradesh, somehow how all of them they come together and develop a single platform, and we can utilize this expertise and making our Madhya Pradesh as a in the top list of having their ecosystem, this kind of ecosystem in Madhya Pradesh and at country level or as well as global level. So just to trigger this session, that as I have already said that there are three categories of people sitting in this panel list, like people from academia, people from industry, and people from scientific laboratories. And each one of you has a different perception of looking at the challenges and opportunities, especially when you talk about the development of semiconductor manufacturing or display manufacturing ecosystem in Madhya Pradesh or in India. So let us start with the challenges, how the industry basically look at this particular problem. And so that we can trigger this session, and same question will be to the the academician, how they perceive this particular problem. And then of course we'll have discussion with the scientific laboratories, because scientific laboratories are going to play a very vital role in connecting these two institutions, academia and industry, altogether. Because scientific institutions, the laboratories like in Indore, there is a laboratory, RRCAT, and there are other laboratories. And in the Bhopal also, there's MPV, and there are other units in Madhya Pradesh. And in Gwalior also, the DRDO is there. So likewise, there are few industries in Madhya Pradesh. How these scientific laboratories, so how these scientific laboratories can make a very good interface between industry and academia. So let us start with the our panelist, the speaker from the academia, not so academia. Let us start with the industry people, and we have with us Mr. Preet Yadav, and there is no need of giving any introduction to Mr. Preet. And Preet is a very senior person in NXP Semiconductors, and a lot of areas he has already worked. And we had a chat with him yesterday also. So Mr. Preet, can you just focus some of your thoughts on this? How you look at the opportunities and challenges in Madhya Pradesh, especially when we talk about the semiconductor since development and display manufacturing.
Thank you, Dr. Anurag, and good evening to everyone, my co-panelist here. And thanks to MPVS for inviting us and stitching us together. Be here, as you rightly mentioned, we have representative from industry, academia, research bodies here, and all of them, we need to work hand in hand together to take our ecosystem to the next level. So as you rightly mentioned, I think the last couple of 10 days are quite energetic in Semicom. Indian Semicom, I would say that we are kind of writing history. Okay, so the kind of decision our government has taken, and I also try to contribute in bits and pieces in those deliberations. So as you rightly said that huge 30 billion kind of commitment is being made, and I think largest ever if we go back look back our history. At the same time, during the same time, our respective honorable Minister of Electronics Information Technology also mentioned that almost 20% of global semicom engineers. So it is part of the those discussions that the 20% of global semicom engineers, they are from India. Okay. So if you see all across the globe, the
We have different countries that I would say they are running at different pace and at a different maturity level in this whole semicon domain. But if you stitch them together all, so about 20% of them are from India. Okay, so it's like we are producing probably world-class talent, and we are letting them go and build across the globe the next level of semicon. Okay, so from from my perspective here is that there's no doubt or no question about the strength or deepest mindset we have as a Indian DNA. Okay, but now how do we encash this all is something we need to work on. How do we get them a value on our hometowns, on our home soil, so that they need not to look back somewhere here and there. At the same time, these all enriched experienced persons who are working different parts of the globe, they have learned and went to a good depth and have gained such experience. How do we get them back? So if you go back and see the Taiwan history, TSMC, it was so I'll not name the person, we know whom we are talking about. So he was the one who came back and he said, I'm gonna go back home and I'll do something differentiating, and which is a world example as of now. Everyone looks towards TSMC when it comes to manufacturing. Okay, so how do we do such kind of miracles here is something we need to brainstorm on. And the one part of it is how do we multiply our manpower. So if I'm not wrong, we were discussing a couple of days back also, Prasandrag, that 2 decades back, our VLSI PhD holders in whole India was a 2-digit figure. We were not even 3 digits. Okay, and within last 2 decades now, any institute you go, we have center of excellence in VLSI and a lot of scholars we are producing. So I think we have addressed that part of it. So now it comes, how do we encash these whole experienced folks to get to the next level of things. So I think initiatives like C2S, which our honorable minister mentioned, that they want to get with about 25,000 more manpower. So I think those all are well taken up, and we are eyeing for about 1 trillion digital economic and about 5 trillion GDP by 2025. And for that, now we need to work on some. What I would like to mention particularly here is that what worked in China is something which might not work for us. Okay, so everyone has a different thought process, different way of looking into things, different infrastructure, different mindset. So we need to come forward and look for our strengths, and at the same time our weakness, learn from the other experience, but at the end we need to put them, model it up into our way of working. Okay, so I think we need to come with our own indigenous way, and I think that's where even the government is now focusing on. It's not that you do a huge investment overnight and fill up the city with fabs. Okay, but if you're not if you don't have a good quality product out of it, there is not a customer queue, then those whole huge investments are of not used to it. Okay, so I think the beginning is done, and I am I repeat it many times that beginning is half done. So it's like let me give you a corollary of a newborn. So initially, whenever we have a newborn, the first thing they do is they start crawling. Okay, after crawling, they start walking. The moment they walk with such a rapid pace because they just want to get to the other end and stop. Okay, so I think we are now on that rapid path. Okay, and post that, the next stage what we need to focus on would be as let's take back again the example, they build up their strength, their muscular power, so that they gain those depths and then start running fast on it. Okay, so I think the crawling part is done. We have a good push from the government side, and right skilled senior professors like researchers like you. Okay, so now second part comes up, how do we get our indigenous products? Because if we see from research perspective, we have excellent research being done. As I was mentioning that I was reviewing one of the paper for a journal. So this guy, he was talking about fixing up something in 180 nanometer. Okay, so 180 nanometer is well talked and done story. Okay, people are talking about gate all around technologies. Someone did a press release early this week about about 3 nanometer chips they are coming up, and they said you need to only recharge your phone once in a week. Okay, so that's what we need to have more research which is yielding us products. Okay, we should not stop at proof of concept POCs, because now the aim these days is, okay, I'm doing my research, say maybe a PhD or master's scholar, that I should have 3 publications or 2 publications, whatever is the criteria. We need to seed these brains that we should do a research which is product oriented. Ultimately, we should have a product made in India. Even if we are well catering to our population, we are good enough. So that thought process from POC to product is something I would like to emphasize on as a starting thought from my side. Thank you. Professor Anurag, you're on mute if you're speaking.
Yeah, thank you, Preeti, for focusing on very important areas we need to be nurtured, and especially the talent building and looking at the POCs and the quality products. These points are really very, very important. And we can take the example from our neighbors, like you have given example that how they develop the system there. And now let me invite the one more person from industry, and from ST Microelectronics, Dr. Ashish is there. Dr. Ashish?
Yes.
Yeah, Dr. Ashish, yeah. Yeah, Dr. Ashish is from, he's a senior design engineer at ST Microelectronics, and it's a well-known company in India, ST Microelectronics, and I'm sure his experience will be completely different, because there are many students visiting ST Microelectronics from our institute as well. And let's see that how he looked at this particular problem. Yeah, Dr. Ashish, please.
Thanks, Dr. Nurag, and thanks, Preet, for a very nice start of the discussion. So I agree that India should start in this direction, and the focus on products and indigenous products is also very, very important. It has to be a very, very long journey for creating an indigenous product. Being in MNCs, maybe myself and other colleagues also might be realizing this is going to be a very, very long journey from concept to realization of a product. What I feel at the moment that all forces, industry, academia, political, everyone has to scramble today in India to encash on this opportunity that this pandemic has provided. This opportunity, the semiconductor shortage, is an eye-opener for India. This is not only strategic with respect to say automobile industry or any specific industry. This is also going to impact all the dimensions of our country. May it be financial, may it be defense, may it be automotive, medical. So all segments are heavily dependent on this. So this is an eye-opener today, this event, the semiconductor shortage that has led, in fact, expedited this decision by the government. And we should take the opportunity to encash this in a proper way. And I think that every state should have its own plan, maybe. And what I see that MP also being rich in the resources and the power generation infrastructure that is rapidly developing. So the opportunity that this state is having today to come forward to take initiatives to offer good incentives to the private players who can show a roadmap or establish a good say fab is very, very important. Today, we should not think about what revenue we will be getting, what share of, say, the profit we will be getting or like that, but to a platform what the India needs for its national security in all aspects. That is important. Now, the second point is for the resources, talents. I don't see any challenge getting talents today in India. If India can manage to provide talents and resources to the global design houses, semiconductor ecosystem, this can also cater to our own need. Any initiative that will come to India that will have no dearth of talent today. So, in my opinion, today, what is most important for us is to align between industry and academia and to encourage this opportunity to kickstart this program, and also the political willpower, political helping hand. This should not be the only initiative approval of the 10 billion. I see this as the very first step in this. If you see the scale of investment that is required for the semiconductor ecosystem, I still see 10 billion as a very small amount. The figure may look like to be very big, but this is a small amount, but this is good enough for a kickstart. So that's my first point. Maybe we can proceed with others' opinions here.
Thank you, Dr. Ashish. You rightly said that the cohesive effort is needed. Whether we talk about academia, we talk about industry, startups, entrepreneurs, and of course, the government policies are equally very, very important. And you rightly said this amount looks a small amount, especially for this particular industry. But yeah, somewhere we have to start. So this is a good start. And like the resources we have said, it is very true that he has also said the same thing, that about 20%, manpower talent is from India only in this particular sector, and there is no dearth of having the talent or the manpower, skilled manpower in this area, especially in India. And one point you have rightly mentioned that every state should have their own system developed with the help of the state government, and of course there is support from the central government as well. But why not from Madhya Pradesh? We can start, and let us have the views from other expert as well as Mr. Narendra Singh. And Narendra is from Madhya Pradesh, and I was going through his biography and how he has developed, how he started his career, and he's founder and CEO of RAG Bank, and it's a data center company. So how he looks at this particular problem, because he is directly working in Madhya Pradesh and he might have faced a lot of challenges during the development of various phases of establishing his own company, RAG Bank. But I think in 2012, somewhere you have established this company in Madhya Pradesh. And Narendra.
Yeah. So thank you so much for inviting me in this conference. I'm the one who's facing biggest shortage challenge while like bringing hardware from Taiwan, China. It's very difficult, and there is a huge shortage. Customers are waiting. The waiting is like 6 months, 12 months to deliver their project, and it's I think a right time where the government has to step in. It should be in earlier, but it's a good, like wherever we start is a good, and that's why I thought, why not look into this category. I'm a consumer. We buy a lot of chips for servers, and we assemble servers. We decided, like, why not solve this big problem? And we decided to, like, okay, let's connect with industry, academia, and everyone, bring together and come up with the product, indigenous product, where we can create a AI, machine learning, and cloud for our customers and for a global client. Currently, in our operations, there is a huge shortage of CPU, processor, chip, everything, almost everything. And we decided to, like, jump into it and start manufacturing, or initially assembly, then go into further part of it. In Indore, now we are setting up another unit for manufacturing. We are going to, initially partner with the industry, academia, and source the component and build motherboard and then source chip from Intel or NVIDIA or any providers. And we are also open for open source chip, which we connected with IIT Indore, and IIT Indore got a brilliant student who's already working on those open source chip side. So we are willing to invest. We know it's a long journey. The product will not deliver immediately, but we have to start somewhere. So yeah, so that's what we have given a thought, that let's start somewhere. And because without cloud or without technology, nothing will move. In this pandemic, we have seen that factories, digital transformation, everything is dependent on the servers and cloud. And this is a huge opportunity for India. And I think government should allocate more budgets to research institute than the fab units. Absolutely, fab unit is going to be execute that, but research institute is going to work on the quantum computer side 10 years ahead plans. So they need a lot of investment. And as an individual or as a company, we cannot invest much money because our investment, it's all, we have to manage everything. So 3%, 5%, not more than that, we cannot put in R&D. So I think government should support this. Thank you so much. I think that's my thought.
Yeah, thank you, Navin. You rightly said, I mean, we could find that there's one consumer among us, and that the industry will come up and they will develop, and there is a direct, consumer is available with us in Madhya Pradesh itself. And so we take note of yours, and we'll sum up, while we sum up, we'll include that point. And we have with us another expert from industry, and that industry is very much required. And what we are talking about with the, and actually we were talking about the talent and the person who is instrumental in making the person skilled enough in this particular area, Mr. Puneet Mittalji. And Puneet Mittalji is CEO and founder of VLSI Experts Private Limited. And as I said, he is more interested in developing the skilled manpower in the VLSI sector. And of course, those are interested in getting themselves deployed in a lot of VLSI industry companies in India and abroad. So we'd like to listen you as well, because we have interacted with industry as well as the academia people a lot, especially the students. Yeah. Puneet. Can you unmute yourself? Yeah. You're not able to unmute yourself? I think there is something. The organizers, can you please just check, is there any problem at your end? He's not able to unmute himself?
I think the host can unmute him.
Yes, I think it's the conference organizers, the host, anybody is there?
Hello. Yes, sir.
Yeah, just please check Mr. Puneet Mittal's, audio. There's some issue with that.
Sir, I cannot see him in the attendees list.
But he's there.
Yeah, like he can unmute himself.
Okay, Punitji, can you do one thing? Just please, log out and log in once again, and I'm sure you will be your audio will work. Okay, so by that time we'll take cues from the one person from scientific laboratory, Dr. Jai Gopal Pandey. Dr. Jai Gopal Pandey is from CSIR Siri Pilani, the principal scientist over there, and he has contributed a lot in the VLSI discipline, and he's interested in cryptography as well as FPGA design system. Dr. Jai Gopal, how you perceive this particular area, and what are your views basically in terms of the challenges and opportunities?
Yeah, thank you, Dr. Srivastava. And we have discussed in this forum already, and there are a lot of things which are still open issue. Like we are discussing about the semiconductor ecosystem, and we heard that we are still procuring item from Taiwan, China, and heavily dependent upon that. And the shortage is still because of that. Here in India, we have all the model, supplier, customer, owner model. Still in this forum, we have all these kind of people, like supplier is with us, customer is with, and designer is also there. It means in India, we have all the talent. So government has done a great initiative, and I'm sure that indigenization of process is at a good pace, and government is also funding and encouraging semiconductor laboratories like Cycle G is also there, Deep Cycle G, and to us also. And there is a lot of open problems. So many industries and defense and strategic laboratories, they are come together because of that initiative of government, and they are forming a pool of problems so that can be solved jointly. And in my opinion, there should be a problem-oriented solution. Like Preet has mentioned that it should be product-oriented problem. We should provide a problem so that there can be a product. In result, not only publication patent, it should be in the form of product. It means we are providing problem-oriented solution, and solution should be in the form of product. It can be a small product. It can be an IoT enabler. It can be AI enabler. It can be an architecture. It can be an AIP. And as when we are talking for fabless, so all the game lies with IPs, and we do not have a lot of IPs with us. In India, we do not have IPs. So we need to create pool of IPs so that it can be fit in this ecosystem. And when it is available, we can realize a great product with this pool of IPs. Also, I think shortage of manpower is still there. The trained manpower, degree holders are many. There are many degree holders. When you advertise, you will get PhDs from good institutes also, but you will not get the right person to do that small job. Any degree holder cannot. So we do not need degree holders. We need a right person so that they can solve problem. And problem is still these are decade-old problems. Like I want to design a mixer kind of thing. I want to design an SoC, basic SoC using open source. You have mentioned RISC-V kind of thing. So there is a set of people, they know analog, some know RF, some hardware, some software. But nowadays it is a combination of all. So we need a set of people in the form of architecture so that they can form product, because product does not see it is a analog digital, it is a product. So co-design is another field in this ecosystem. Semiconductor fabless, when we say, so there will be IP, and for that IP there will be master, and master is nothing but it is a processor. So we need hardware software co-design kind of person so that they can tackle the problem at the level so that we can give product. So in my opinion, IP crunch is there, and we need to do something for that. Thank you.
Yeah, thank you, Pandyaji. And you rightly said that there is a need of having a pool of IPs that is very well required. And you rightly said that the degrees are not anymore required. You need the skilled manpower, and especially that expertise in that particular domain, and that may solve the purpose. And person having PhD or you having a BTech or MTech doesn't matter. You need simple people who can simply solve the problem. And so that's why, and I think special sessions are needed. And I think the right person is Puneet. And Puneetji, now I think your audio is working.
Yeah, perfect. Now it's
Yes,
working.
very good, very good, very good. Yeah, I would like to listen because Pandyaji has already triggered, and
Yes.
you be ready with answers.
So first of all, thanks a lot, Dr. Anuragji, and thanks a lot, everyone. So, like Dr. Anurag already introduced me, like I'm basically playing a role between the industry and the academia in one way or other way. So I worked there almost like 15 year, and now I'm just on the other side of the industry. So I can understand like what is the industry is looking for, what are their challenges, and the same goes on a academia side also. Like in a academia side, what are their challenges? So in terms of uh, the semiconductor, if I will see the and the which I can just also say like, okay, in a next few year, the problem where the problem is going to be there, the challenge is going to be there. That's basically uh, it's like we will have the infrastructure, we will have everything on place, but when it comes to like uh, who is going to work on that particular part, like manpower, if we will talk about, like who is going to design the chip. It's not chip is like not designing like right now we are just doing the automation and everything. If we are talking about something Atmanirbhar, if it is like made in India thing, so it's not like made in India doesn't mean like, okay, we will just outsource, we will just take something from here, we will just give it to outside India, or maybe there is a something we will just import from there and just we will build on the top of that. Basically, what we have to do, we have to build everything within India itself. Now, I know like when it comes to the manpower, we have good talent. That's there is no doubt. We have resources also. So resources in the sense the engineers we have, if you are talking about. But the problem is, or the challenge is, like they don't know like how to design a chip. They can, so basically they need a grooming thing, I would say. They need a we have to reshape them. Now, who's going to do that particular part? So like here we have everyone from the industry. Like now the thing is it a industry problem to solve? Like NXP, ST, they are going to solve this particular problem. Yes, they are doing their part, but how many candidates they can train? How many engineers they can train within a year? Maybe they can, if ST decide today, maybe they can train 1,000 people, 2,000 people. I think that's maybe the maximum they can train in a year. Same, they can the NXP, if they will decide they can open a new center maybe in a India, or maybe a couple of centers, they can also train 1,000, 2,000, 3,000. But the challenge is like the the type of environment we are talking about, the infrastructure we are talking about, the future we are talking about. 1,000, 2,000 people are not going to like can do everything. We need maybe 10,000, 20,000 people. So till now, like I'm from the last 15 year, 20 year, everyone was talking about the fab within India. When the fab will come, the job will come, the semiconductor market is going to boom. Now the thing is like everything is there. Now within a like government decided everything. For them is just like deciding, just making certain arrangement. They can do it within a 6 months, and they did it. Now the thing is like it's now up to us as an industry what best we can do it. Now same goes with the academy also. So if I will ignore, if I will just bypass this tier A organizations like the institutes, tier B. Now all of us know very well, like when it comes to the education within the college, like rightly said by Gopal ji, like it's not a degree. We are not looking for the just a degree. It's just like we need a talent, the experience as per the industrial level. Now, how we are going to bridge that particular gap? So right now, the if a engineer, means I'm just talking from the very basic level. If an engineer don't know, like okay, what is a VLSI? Like that's the truth. Like if you are going to ask what is a VLSI for them, VLSI is a one of the subject. That's all. Now, if we are, I'm not talking about the IIT, like, okay,
the VLSI in IIT or the NIT. I'm just talking about within the MP itself or within India itself, there are a lot of private colleges. Now, just if we will just talk to them, what is the VLSI, then they will just say like, okay, in the 7th semester, 6th semester, 5th semester, there was a subject that is the VLSI. Or maybe for them, the VLSI, the semiconductor is just a AND gate, NAND gate, designing the circuit. As an industry person, I know, all of us know very well, like, okay, that is not the VLSI we are talking about right now. Now, that's the challenge. And I would say that's the opportunity also for the institutions' point of view also, like how they can just work on that particular direction, just make the manpower as an industry ready. And that's somehow industry also have to play some role, like maybe they have to not just like just one association or the two association, maybe they have to take something else which is like different from opening a college or just giving the internship within the company. They have to do something extra which can help to generate maybe 10,000, 20,000 in a year. And when, so engineers point of view, we know like, okay, electronics engineer, there are almost like 5 lakh engineers per year. But I'm not talking about the 5 lakh engineers per year. I'm just talking about 20,000, 30,000 semiconductor VLSI engineer. Now, as a MP, like Dr. Anurag, you were talking about the MP. I think that's the area where we can work. We, in the sense, all of us, we should work in that particular area. Like within an MP, in a year, how many engineers, VLSI engineers, semiconductor engineers, we can I'm going to use a word produce. How many engineers we are going to produce, and how can we contribute within the whole ecosystem? That's something we have to figure out. That's all. That's all from my side.
Yeah, thank you, Punitji. Thank you, Punitji. You have rightly said, and the thing you have said that the manpower is still enough so far, or which is available, may not be enough. And for that, you need to think of coming out of the only bigger institutions, IITs, NITs, or IITs. You need to get collaborated or get trained the people or the students who are in the private institution or other institutions other than this. And they should have the feel of that, this particular area. And this is very important area. Government is pushing a lot. There is a big scope. So when they start feeling that, this is a very, very important area, and then then only I think they can get interested, and they will be interested. They will not simply talk about VLSI simply means designing a circuit and all that. They will look at, there is a big scope in that. They can become a very good engineer in a very good company, and also they can have their own startup or something like that. So this is one, and so we have one Mr. Deep Sagalji from SCL India, and Deep Sagalji. So we had the chat in October as well. So nice meeting you once again, Devji. So what are your views, because we had chat in October, and what different you have in your mind discussing with this panel?
Thank you, Dr. Anurag, and greetings to my co-panelists and all the organizers of the conference. Very good initiative by you people. And also in the recent days, what you were mentioning in the beginning, Government of India has announced a mega plan for the country, a mega plan to really take this whole country to a very high-tech domain of semiconductors. Now the question you raised was, how do we see actually this situation? There can be multiple views of this situation. One can be, are we thinking only short term in the time frame, or are we thinking of a very long time policies or long time outcomes? The second can be, are we really thinking of only the commercialization as the one aim, which is a right aim to cut out the India's import budgets, but at the same time, there remains a very high room for research activities, as one of the co-panelists touched upon, and to really make indigenous efforts and go towards the all self-reliant or Atmanirbhar Bharat. I would also say that it is not only that government has talked of the display fabs, they have talked of, and also the CMOS lines, but they have also talked of compound semiconductors. I am giving one example that these are the areas, compound semiconductors, photonics, and the silicon germanium technologies, which I feel so that beside the CMOS mainlines, like maybe memory or the digital IPs or the processors, we should right now focus upon these areas also as well, because a lot of opportunity remains in these areas. And I feel so that that there is a high opportunity ahead of us by the government of India providing these technologies also in the same news issues which they brought up. Now the question is, how will we really cash upon these things, or how will we really work upon these things? Now I want to start, or I want to say at least on the optimistic note, that it is really possible within our country to build up right from the concept building to a working silicon, working under the all extreme conditions of temperatures, radiations, everything. It is really possible to bring up these type of chips all well inside the country, right from concept building to working silicon. Even it can be first time pass. The question is, those areas where we have to cash upon may be very niche. Maybe, for example, if I give you maybe BCDs, maybe RF, where not everybody is focused upon. IPs can be brought up in these areas also, and research can continue in these areas also, and talents have to be nurtured accordingly. Okay, we can really go well on the processors, but many of the IP rights actually belong to some other people. And not only this, let us talk of EDS. Now, today we are talking of Synopsys, Cadence, or Mentor, where all the EDS are actually the dependency is on the other people. But I know one company in India which has taken a good initiative in bringing up even the softwares, because there are security issues, embargo issues, single point dependency issues. So in nutshell, it appears that if we focus right now, we are making a big buildings, we are making a very mega plans. It is very good, but onus comes upon us to build up the fundamentals. And we cannot ignore, no nation can ignore the fundamentals in this such a grand plans. And fundamentals, when they come up to, I think the right institutes, the start point is Dr. Anurag, I will say it is the academic institutes in a joint collaborations with the research laboratories, in joint collaborations with, of course, my industry partners and all good industries. But we have to really see the curriculums. Everybody likes, when he joins the industry, everybody likes reading the Razavi. Everybody likes reading the Alan Hallberg. Everybody likes reading Jan M. Rabe, Digital Integrated Circuits. We all have read it. We know how much these books have played a role in our life. Yes. So the viewpoints they have given to us has remained with us over the years. I think academia has the junction points have come, and we have to really make a very specific nurtured talent specific towards the projects. And then once upon a time it was a fab and fabless. Once upon a time the industry got disintegrated somewhere in 1987 with the start of TSMC. But with the complex systems emerging, some integration is again needed. We need the people right from system designers. Now let us bring a pool of people in the country who are the system designers, who know right from the top what specs are to be defined for what particular thing. and then break down these collaterals and verticals even up to the site industry, that what way the testings will happen. So I want to touch all the ground realities on which really any system, whatever we talk of, even the mobile phones, even the automobiles, even the rockets, anything, missiles, everything works upon, and we all know it. Now, onus lies upon us how well we can integrate in the days to come, how well we can really educate our next generation, and for a very long-term plans of developing completely indigenous solutions within our country. Yeah, I would stop here. Thank you very much for this effort.
Thank you, Deepji. And you have rightly said that short-term goal as well as long-term goal both are very much required and different domains, and making it possible the Atmanirbhar Bharat and Make in India possible. I mean, the mission of our Honorable Prime Minister. And you rightly said that there are two other areas need to be nurtured, like for example the aspect of the material which are very important, like compound semiconductor, and not only talking about the elemental semiconductor, silicon and germanium, but we need to focus on the photonic band gap material as well, photonic material as well. So these, and that's how, you rightly mentioned that, the fundamentals are very much required. And whenever somebody is entering in the industry or in the scientific laboratory, it's the very first thing that, to build the confidence that your fundamentals should be very strong. And in that, I think the role of academia people is very important. And I think now let me invite the people from academia. You rightly triggered now to invite the academia people. And we have with us Dr. Shailesh from LTU. Shailesh, are you there?
Yes, sir. I am
Shailesh.
available.
Hi, Shailesh.
Hello, sir.
Yeah, Shailesh. So because we are running short of time, and
Yeah.
maybe quick review from your side, but I think you have already heard, people from industry and their needs basically, and I'm sure not now you can
Yeah.
make a very good remark on the role of the academia.
Thank you for this opportunity and greetings to all. And I deeply agree with Puneet ji and Deep ji that we need some kind of a reform here. And as an academician, I also mentioned this thing in the month of October that the courses that we are running are very generic, very much generic. Like, okay, we have electronic telecommunication, electronic instrumentation. They are very generic. They are not at all providing any deep information, or one can say the knowledge that are essential for any industrial driven system. We know that we have a total 4 emergencies, and this is what I proposed last time, that we have to develop the skills specific to these 4 emergencies. 4 emergencies means like a standard CMOS or mixed signals or RF for some specialty forces. Similarly, as I have mentioned, we want some kind of a cell in our university or in our institutes which directly interacts with the industries and try to identify the problems what they are looking into. I am not saying that we promise the industry that we will provide the solution overnight, but at least we should be aware of like what kind of problems they are looking into, what kind of the things they are interested to learn, what to say, from the students, so that they learn there. Also, one of the important point that as we work in the VLSI domain, so there are total 24 skills that we required, and out of these 24 skills, 16 they are totally software based. We know like nowadays that there are no more interest in the electronics, people are moving toward the computer science. So this was my proposal in the past as well. Try to incorporate the software languages like Python, C++, Java, TCL into your system, into the electronics course, so that at least they are much aware of what kind of the things that the people are using in the VLSI. And similarly, if they didn't manage to go inside the VLSI system, at least they will get something in the software domain. So this kind of changes which are really required in our electronics domain, so that when the person will enter into electronics, at a one moment he will thought whether he has entered in the computer science department or in the electronics department. Then most important next point is that as an academician we think that the roadmaps means sorry, the process technologies, they are more important than the roadmaps. So as a part of the university, we are supposed to create the roadmaps which are essential. So we are not supposed to create the roadmap according to the process technology. We are supposed to create the multiple roadmap, like okay, like high performance systems or SOCs or something like low power or MSRF. It depends on the scenario, like what exactly we want. And this is how, when we put all this thing on the plate for the students and start training him or her from the starting of the first year, then in the next 4 year they are at least 30% ready for the VLSI industries. And this is how we can achieve our goal. In order, for example, let's consider the MTech project. So instead of making like a giving them the opportunity that okay, you just go and do the project individually, just collect them on a single bench, assign the SOC based problems to them, so that everyone is working individually and in the end you have a product. When you create this kind of systems, or when you implement this kind of pedagogic activities within the university or the any institute, I am definitely sure that we will fulfill the requirement as mentioned by the honorable panelist. So I would like to conclude here. Again, I am saying to you,
Yeah, thank you,
we
Sarish.
need the reform. We need to reform our academy.
That's right. Yeah, yeah. A lot many reforms are needed at various ends. Various ends.
Yeah.
Yeah. So
Yeah.
we
Thank you.
have with us Dr. Ambika Prasad Shah. Ambika, are you there?
Yes. So
From ID Jammu. Yeah.
yeah,
So
thank you so much, sir, for inviting me for this discussion, and I'm very much happy like to be part of this discussion. And thanks to MPBS for inviting me. And I think I'm very much surprised. Like MPBS has hosted 17 conferences and three conclaves, and that is really a very good effort from the team MPBS. So many congratulations to the team. Coming back to the bridging gap between industry and academia, this is really a serious challenge. Like, see, uh, suppose as of now we are seeing the currently the technology, like the most of the foundry they have started working for the 2 nanometer technologies, but still the academia whatever they are doing research at 65 32 or something like that, not more, not below the 32. Okay, so the major problem is like industry they are working at 2 nanometer 3 nanometer or 5 nanometer technology. They are developing their product at this technology node, and the institutes or the academia who are working at only like 65 nanometer technology. So once they complete their education at the academia, they will not be able to cop up what the industry is doing. So this is one of the gap which we need to fill. So might be one of the solution could be like the joint supervision or the we must get some statement from the industry, and that should be given to the academia, and the academia people can try to solve those problems which are which really industry is facing. So this could be one of the possible solutions that can gap this bridge, because see, without that it's quite difficult. Like they are working at 2.5 something like that, but we are working at 65 nanometer technology. We have the only foundry in India which is 180 nanometer, which we can fabricate from SCL Mohali. Okay, and if we are ready with the chip and we have the tested data, might be that tested data your efforts will not be sufficient to fulfill the criteria of what the industry is needing, right? So this could be one of the gap. So the first solution I just given, like this could be like we must get some problem statement from the industry and the academia should solve, and the PhD or whatever the degree we are giving from the academia side, that must be given based on the objective what they have completed based on the industry problem. Second thing could be like to gap this one, we can have some consultancy services that can also be provided to the academia. Like see, we have heard something like the TSMC need the 1600 the trained manpower for their Arizona lab, Fab lab, but they are unable to get the trained manpower. Okay, so this is the problem. Even though they are setting up one more Fab lab in the Arizona, but still they are not able to get the trained manpower. So the problem is like they expect the manpower should be well trained as per their requirement, but the academia are not able to provide what kind of manpower is needed to the industry. So to gap this one, like we can have the consultancy, like the professors who are working in the university or the institute, they must know what the industry wants. They can try to solve some of the problems which is coming from the industry side, and that may help to get the actual idea, actual picture what industry is doing. So that may be one of the solution to bridge this gap. Okay. Another problem is like, see, the proper training is really very important. Whatever the students are doing, just they are going through the lecture videos and everything. They are attending the classes. They know the concept for how the transistor or how the MOSFET works. But how actually we can fabricate those transistors, this is a really serious problem. So training, proper training, the real training, what industry is needing is really important. One more important thing that we have to consider, like whatever the things we are developing at during the master, during the PhD, that technology must be translated into the product level. Simulation data, like, and the publication is not a sufficient, like to get the PhD degree or to get the master degree, just you have to publish 3 or 4 papers, then you will get the PhD degree. But there is no many of those data if you are not able to do a 10% of what the industry wants. So the technology transfer or technology kind of translation is really important in this case. Uh, Another thing, like if you see, like just Dr. Jay Gopal will said, like we are lagging behind, like in ED and IP, core IPs. Okay, so if you see, like 96% of the portion is covered by the US foundries or US or the Europe only. Okay, we are very less in the EDA side. Yeah, definitely we are very good in the circuit designing side. We are very good in the analog side. We are very good in the sensor side, but not on the IP side. And this is the serious threat that we have to consider. We have to, like, we are talking about the Fabless and Fab India or something like that. So this point must be considered. Like we must work as per the need. Okay, so this is also one of the thing, important thing, like nowadays most of the people are talking about the quantum computing, something like that. But see, as an academician, we have the limited resources. We cannot develop our lab in a such high level that can fulfill the requirement of the quantum computing. Okay, so in this case, a joint hand with the industry is also needed, right? So without industry, we cannot do any work on the quantum side, right? So this is also one of the things that we have to do. Okay, and but the thing is how to start with this. Okay, it requires some investment. Uh, like institute cannot do, like academia cannot do this. It requires some industry support, but industries are not supporting to do this. So yeah, we have to bridge the gap. We have to come together, like, yeah, this is the problem statement what industry wants, and this is the manpower which we can get from the academia, and they can try to solve it. So this is what is what is the requirement for and this is the need of our. So yeah, this is what I can say.
Yeah, thank you, Dr. Ambika. You rightly said some of the challenges and how to bridge this particular gap, and the role of industry as well as academia people are very much required. And there is a need of the trust building. And I was discussing with PG yesterday. The trust building is very much needed, and for that we both have to come forward and put our best effort in bridging this gap. And I think we have Dr. Anirban also from Rose Institute, who's organizing this particular conference. I'm from IIT Indore. Anirban, are you there?
Yeah, hi. Am I audible?
Yes, Anirban. Yeah, you are audible. Yeah.
Yeah, nice to see you everyone here.
We'd like to listen you as well. Yeah, please.
Sure. Yeah, just quickly go over my comments actually. So having heard all the people, I think I know quite a lot of people out here, including Preet and Ambika and Jayagopal, a lot of people, including you, and a lot of people here, and it's great to listen to the perspectives of the industry and academic guys out here. But I'd like to bring a new perspective into the discussion, which is how many of us are actually looking into the security and reliability perspective of the chip design process. Okay, so depending on what application we are actually deploying our chips, whether we are doing it for spacecraft application or radiation-induced environments, or if you're actually trying to import a lot of third-party intellectual property codes and integrating with the SOCs. So how much can we trust these external 3P IPs that are getting integrated into the system? And if you're not able to be completely trustworthy of them, what can we do? What are the different technologies? So a lot of work has actually been done in this area, specifically mostly in the US. And of course, I mean, in the IITs as well. So I would really encourage the industry and the academic partners to come together to build a hub where the security perspective and the reliability perspective can be specifically taken care of. Specifically, in case there is an external invader who's trying to reverse engineer the chip, what can we do to thwart or hinder their intentions? What type of technologies we can deploy? In case there's any backdoor hidden Trojan, which we call as hardware Trojan in the 3PIPs, what can we do to safeguard our chips? If there's any radiation-based transient faults that can occur because of which a bit flip can occur directly in the processors, what can we do to safeguard against them? There are so many things that are still, India is actually lagging behind. Forget about Madhya Pradesh, India as a whole is lagging behind. So I think there needs to be a collaborated effort from both the academia and industry to take care of that. So that's going to be my closing remarks. Thank you so much.
Yeah, thank you, Anirban. So we are reaching to the deadline, and the time limit we have given by the organizers. But I would like to hear all of you once again. Before that, let me just sum up some of the things you people have mentioned, and I could find out very interesting what need to be done at our end as the organizer, as a recommendation to the government of Madhya Pradesh, so that they can think of and what could be our role as an academic person, or what could be our role as a industry person. So there is we all feel that there is a need of the consortia, and which include the academic people as well as industry people, and also the people from scientific laboratories, and also the people from the state government as well as the central government. And rightly said by one of the panelists that there is a big need of having our short-term goal as well as long-term goal. It's very, very in various domains, of course, in various domains. Whether it is resource development, whether it is a startup culture development, whether it is a fundamental course development. I mean, many areas there should be short-term as well as long-term goals are very much required, and those goals are very much required in making possible the Make in India program and the Atmanirbhar Bharat program. And there is people feel that there is a big need of resource development, and resource is a very, very big umbrella. So a lot of effort is needed at various ends. And people feel that there should be effort on translating concept to the product with the realization. It's very, very important, the idea. And focusing more on having our own IPs and reducing the dependency on China and other countries. And that is how we can think of Make in India program successful, and Atmanirbhar Bharat. And for that, we need to have the courses on futuristic problems. And some of the speakers were rightly mentioning that we need to focus on two areas, the application areas. Accordingly, we should select our problem, whether it is in academia or industry. Of course, industries are money. Yeah, in business, they doing the right business. So wherever they feel there is a need, and that's why there is a proper sync is needed between the academia and industry. And the industry people, they always feel that the people who are joining their industry, they are lacking in the fundamental knowledge. And so academic people, they have to put a lot of effort in designing their courses and putting their best effort in training the students on the fundamental part. Very, very important. And course content and curriculum should be very, very focused one, and we can think of starting a certificate program or diploma program. Like somebody was saying that we are not much interested in degrees. Somebody is having PhD degree, but he may not be of use to industry. But someone who is simply having a BTech program or some other degree, but he's skilled enough to get deployed because he's able to solve the problem. So, I mean, these kind of things will be very, very important, need to be, discussed a lot. And for that, I feel that the focus certificate on a diploma program can be started. And like somebody was saying that that can be possible with the joint effort of industry and, academia people. They can think of having a joint program, joint thesis guidance, as well as, having the short-term program or FBP programs and all that. People from different domain can be, part of this consortia. And when I'm saying different domain, I'm also focusing more on the subject areas. It is not only the job of the people from electronics industry, people from computer science engineering. We can also involve the people from material science. Like, we was rightly saying that the material industry is booming and metals are playing very, very important role in that. Until unless you are not aware of the best property of the material, how you are going to exploit those material for certain device application. So because you cannot focus more on circuit manipulation, you have to think of the making your own device a new device which can perform as per your requirement. And the size also, when you are thinking about the size, reducing the size, metals are playing a very, very important role. And that's why I think DFT was more interested in talking about moving from elemental semiconductor, silicon, germanium to compound semiconductor or other nanomaterials or the photonic material, depending upon your application domain and all that. So this is also very, very important area need to be focused on. And as they were saying, they're bridging the gap of industry and academia. So this is also very important. Think of joint program, and these are few things I think the current institution in Madhya Pradesh they can think of very easily. They can start this program, and for a quality product, rightly said by KG that hand holding is needed. Hand holding is very much required for a startup who is coming up in this sector, and if there is no hand holding, it is very, very difficult to establish him in the market. And that too in the beginning when market is coming up in a big way, and government is also pushing a lot. So next, exploiting our own resources of Madhya Pradesh, somebody was saying is very, very important. I think that like Narendra was saying about this, the exploiting our own resources of Madhya Pradesh, like especially the power, power and training the skilled manpower students which are available in different engineering institutes in Madhya Pradesh. We have the IITs, we have the ICER, we have the NITs, we have triple IITs and other institutions of Rajiv Gandhi Pradesh Vishwavidyalaya. So we can involve all of them together. It is not only the job of one institution which can serve the purpose. We can, like for example, somebody was saying, I think Puneet was talking about that there is a big need of the manpower. It is not only that 2,000 people or 3,000, 5,000 people are going to solve the problem of the industry. You need a big manpower, and not only big manpower in terms of the number, but skilled manpower, real manpower who can really solve the problem. And somebody was also talking about hands-on training is very much needed. It is not when we are talking about the fundamentals, we should not focus on simply giving them lectures and making them theoretically strong. There should be proper hands-on training of those students, whether doing the developing the computational blueprint of the designs or the devices, or also in the laboratory. So the efforts are needed. And technology transfer is, of course, very much required once you are finished up with these fundamentals, hands-on training, and those things. I think the technology transfer is another very important part when somebody is interested in having their own startup or company or joining industry. And last but not the least, very important is problem selection on a specific area. And then one was talking about selection of the particular problem and a specific area. And those specific areas, I think industry can tell much better that say what are the areas they are looking into. And according to that, and I think the course structures must be decided, and we can involve them in course curriculum designing. And then only they can feel that ownership that they are part of the system. And otherwise it is very, very difficult to get them involved, especially the business people. So even a second of these business people are very, very much important. I'm not saying that say 1 second of the academician is not very important, but industry people, their 1 second means $1 million or $1 trillion, right? So so this is all what I could conclude with your deliberations and presentations. And now there's a need of quick remarks from each one of you, maybe for 1 minute, 2 minutes, how Madhya Pradesh, government can think of supporting the idea of developing this particular ecosystem in Madhya Pradesh. So maybe we can start with Preeti once again.
Thank you, Ra, for summarizing well, capturing well all of the discussions. So as a closing point, I would pick up, which most of us, kind of echoed that let's have more of hands-on happening because, if I'm hiring someone, I want, day one, first hour, this guy to be productive. Okay, that's a big dream. Okay, but yeah, to head towards that, let's have more and more of, concept building, hands-on labs happening. Okay, and that could be a central part. The second thing I've seen is we have a lot of pioneering institutions across the India. Can we make center of excellence? Center of excellence like someone who's as Dr. Deep Sahil was mentioning, someone who's pioneer on materials, someone who's pioneering on system level, who could define, okay, to create the system, these all IPs or building blocks we need, and then probably we can have someone who's excellent in say only data converters or only into the clocking circuits, PLL, oscillator, etc. So let us focus. It's because even in industry we have found that we are never not a single person or institution or a group is self-sufficient. Okay, we should work hand in hand, define our targets, and get to this mission. So that's a quick concluding remark I would like to make. And I think as a team together, let us join hands and see what best we could give to the upcoming generation to make a Atmanirbhar Bharat. Thank you. I think we lost Anurag. I could see a red triangle on his name. Up, you're back. Looks like this you got disconnected.
Yeah.
Okay, great.
Yeah.
Thanks.
Okay. So, Deep ji, Deep Sahil.
Okay, Anurag ji,
Yeah.
all panelists have, and you have very nicely summarized the things. And I hope that you will present all these things to the senior officials of the Madhya Pradesh government. Madhya Pradesh has been my birthplace also. So, and in a way attached to this Madhya Pradesh. I will say that I do not have a very concentrated thought right now, but I will say please take some time after this conference. Please arrest all the thoughts which have really come up, and please do visit the industry as a team. Do visit industry and scientific labs all across the country, particularly for semiconductors, and identify the real target goals. And let us then, by the initiatives of maybe Madhya Pradesh government, we can open, as Preet was also saying, center of excellence or any type of body. And I feel that even one or two or three goals will be enough. Let us, we know we cannot be masters of everything, but I still hope that there is a great future through these initiatives of Madhya Pradesh government as well as Delhi government. And I feel that whatever technology you will take, there still remains a room to do the much into it, contribute, and bring up really a good product. But please take some time, and then only start these initiatives. Yeah, thank you.
Yeah, thank you. Thank you. Dr. Ashish.
Thanks, Dr. Anurag. So, in fact, I have a couple of points to summarize here by listening to all of you. While listening to all these talks, I try to remember how these companies like TI, Intel, ST evolved during last 30 years, maybe 30, 35 years. How ST evolved in my career of 22 years. I see always you will find a crunch of talent, but talent multiplies talent. And your needs are always fulfilled, whatever they are. So from the handful of people strength in ST in 1995, ST has grown to 1400 strength today. So this is the gradual journey that we should think about and initiate in this direction, not to worry about the talents. The requirement comes, the facilities, the training programs or whatever it is, those ecosystems will automatically develop and will cater to the need. A second important point I want to mention here is the way you want to develop. For MP, see, when we are interacting in STA, we're interacting with several academia, tons of universities, all IITs, NITs and all. And what I found, see, the principle is you be what you want to be. And the focus of IIT Indore, I have seen, is enormous in this direction. The commitment of your faculty members, your responsible persons are appreciable. See, everyone has resources, everyone has money, maybe everyone will have political willpower. But who has to channelize? The person who has to channelize is who knows what to do. And that is the academia and industry. And I feel that industry is always ready to help, provide a helping hand whenever such an initiative comes. And IIT Indore is best suited due to its resources, its people, its faculty, its research community to kick start in this direction. And that's very important because we won't like to develop like IT industry today is 80 billion exports we are doing. But in this 80 billion exports, are we happy with the situation in IT industry today we have? Probably we should not, even if we have, because we have to provide a foundation, a research-based foundation, an innovation-based foundation to the industry, and that we should all keep in mind to kick start when going ahead with the semiconductor system. Thanks.
Yeah, thank you, Ashish. Thank you so much. Naren, are you there? Naren? I think Naren has left. Okay. Punitji, would you like to make your closing remarks?
Yeah, so I think everyone almost cover everything and you summarize things very well. I just want to add one point, maybe just a thought. Uh, so it's like if you remember like 20 year, 25 year back when there is a IT boom, and at that particular time there were few institutes, I would say private institutes, government and the private institute. Like if you remember, there was a the courses like O level, A level, B level. There was a level courses was there. Similarly, there was a NIIT that NITS, I think, if I remember correctly.
Yeah, NIIT,
So
yeah.
yeah, NIIT that was there, and they have some certificates, and that certificate has a value in the company. Now, on a similar line, if today, I'm not saying as a private institute, maybe as a MP government, you can just work with them and you start a similar kind of a program or similar kind of thing, which is like in association with the government, and that's driven by maybe the industry, some certificate program, which is maybe within the IIT, or that's program is there. And that's not for only the college student, like the BTech student. It's maybe anyone can join that particular program, like maybe the 6 month diploma or something like that. And in that is going to be very specific thing, and that's going to fulfill the requirement of the coming like manpower thing. Maybe that can be done with the help of the government, that can be done with the help of the educational institutes, and obviously we need industry also. They can come, they can just give the project, they can just do the project oriented similar kind of thing. So we can design like 6 months to 9 months of the 1 year similar kind of thing. It's not a degree, but yes, something like that, which is recognized by the industry. So that is important. Like the industry should recognize that particular part. Like on the basis of that, they can get a job. So if we can do something like that, then maybe we can solve this particular problem.
Yeah, thank you, Punitji. I think we have reached the limit, in fact, crossed the limit. 5:30, it's 5:41 now. And Anirban, would you like to make any remark or Shailesh? Anirban or Shailesh?
I totally agree with sir, the panelists, because we want some kind of hands-on practice, and that is only feasible via the close collaboration with the industry. And this is only like the takeaway from my side, like, okay, try to identify the problems which nowadays the industries are facing and try to accommodate those the solutions in our academics curricula, so that we may answer all the questions raised by the industrial persons successfully. This is the only like the takeaway from my side.
Okay. And Gopal Pandey, Jai Gopal ji?
Yeah, I would like to summarize that we should design our own IP with our own security mechanism, and we should focus for earlier is made in India and make for India.
Yeah, made in India, make for India.
Make for India, yeah. Because there is a product, specific kind of product, which is India specific. So what are the India's specific problem? We should focus and design the product which is not exist. So this is the concluding remark from my side. Thank you.
Thank you. Thank you. Country specific problem is very much needed. Make in India and make for India. So that is well taken. I haven't included in my notes. And Anirban, because a lot of appreciation to Dr. Ashish for IIT Indore. Would you like to say something? Because now it's a challenge for you.
I think Dr. Nirban left the meeting. He was supposed to go somewhere else. I just read in the chat. Looks like he
Yeah.
left it, yeah.
Okay, so
Well, I also need to move in next 1 minute.
yeah. So I think now we have to close the session now, and have included some of the points as a closing remark, like center of excellence in a specific area is needed, and there is a need of visit to the specific industry that I have included here, and also the country specific problems need to be focused more on, and sharing I have added one more point because I got clue from someone's closing remark that sharing the success of Indian, startups and companies in the sector, and so that new people, young people, they get inspired, and with the success of any kind of invention, any kind of development took place in any institute or in any industry in India. So they should feel pleasure of that. So with this, these closing remark and this summary, I will be thankful I'm thankful to all the panelists basically who have spared their very precious time, and the organizers specifically who have made available this great knowledgeable people as a panelist for this particular session. And I'm sure that the recommendations I have summed up, and these recommendations I'll be transferring to the organizers, and they will be transferring to the government of Madhya Pradesh. And I'm sure that we'll meet again with new findings, whatever we have concluded in this particular session, and we'll see that how it progresses. Thank you so much. Thank you everyone for
Thank you, sir.
part of this panel discussion and making your best remark possible for developing this ecosystem. Thank you so much. Thank you so much.
Okay, thank you. Thanks a lot.
Okay, sir. Bye. Bye.
Thank you. Thank you, everyone.
Thanks to
Yeah, thank you, organizers. I don't know your name. I'm sorry.
Sir, it's Sumiran.
Yeah, Sumiran. Thank you so much for conducting the session and making it so.
Thank you, sir. Obviously, that was very informative for all the students joining here. And as per the pre-conference, this session was quite more informative, and we concluded a lot. Hopefully, the session like this, MPBS will
Thank you so
do
much.
whatever it is organized for. Yes, yeah.
Thank you so much. Thank you, everyone. Thank you.
Thank you, guys. Thanks. Bye-bye.
Wish you all happy New Year.
Same day.
Happy New Year, sir. I'll request the attendees to be here so that we'll have the rest of the poster presentation. Okay. So we have two students in here to present their poster in person. So the first is from Anurag Sharma. So I'll call Anurag Sharma to present his poster.
Hello everyone, my name is Anurag Sharma and I am from AKS University Satna. Currently I am pursuing Bachelor of Basic Science.
And my name is Prince Kumar. I am his classmate and I am also from the AKS University Satna.
And our topic is synthesis and characterization of a multi-product material for device application. Our जो multi-product material है हमने उसको सोल्जन मेथड्स का यूज करके तैयार किया है. हमारा बैकग्राउंड वर्क है हमारा बैकग्राउंड वर्क है हमने जो मल्टी प्रोडक्ट मटेरियल्स है वो दो तरह की प्रॉपर्टीज को शो करता है जो है फिरो इलेक्ट्रिक और फिजो इलेक्ट्रिक है. हम इसकी इसी प्रॉपर्टीज के कारण हमने इन दोनों मटेरियल्स का यूज किया है जो कि डिफरेंट मैग्नेटिक डिवाइस बनाने के लिए यूज होता है.
हमने इस मटेरियल को बनाने में कुछ मटेरियल्स का यूज किया है जो कि है बिस्मथ नाइट्रेट, फेरिक नाइट्रेट, साइट्रिक एसिड और सॉल्वेंट के रूप में हमने यूज किया है नाइट्रिक एसिड और वाटर. सर्वप्रथम हमने कहते हैं बिस्मथ नाइट्रेट और नाइट्रिक एसिड को आपस में मिलाया, उसका सॉल्यूशन बनाया और एक अलग बीकर में हमने फेरिक नाइट्रेट और वाटर को मिलाकर उसका सॉल्यूशन बनाया. फिर हमने दोनों सॉल्यूशन को आपस में मिलाकर उसमें थोड़ा सा साइट्रिक एसिड ऐड किया और उसे 80 डिग्री सेल्सियस पे गर्म किया जब तक वो सॉल्यूशन से जेल में कन्वर्ट नहीं हो गया. फिर प्राप्त जेल को हमने 150 डिग्री सेल्सियस 150 डिग्री सेल्सियस पे गर्म किया, सुखाया और उसे ग्राइंड किया. फिर प्राप्त पाउडर को हमने एनीलिंग किया 400, 500, 600 और 700 डिग्री सेल्सियस में, जिसमें हमने कैरेक्टराइजेशन में XRD किया स्ट्रक्चरल कैरेक्टराइजेशन के लिए और SEM किया माइक्रोलॉजिकल कैरेक्टराइजेशन के लिए. XRD में हमें जैसा कि आप लोग देख सकते हैं हमें थोड़ा ये ऊपर जैसे कि आप लोग देख सकते हैं XRD डिफ्रैक्शन पिक हमें 27.6 डिग्री, 31.68 डिग्री, 32 डिग्री, 39.41 डिग्री, 45.68 एक्सेट्रा पर हमें पिक्स मिल रहे हैं जो कि JCPDS कार्ड नंबर 861518 से मैच हो रही है जो कि एक इंटरनेशनल डाटा है. और तथा BiFeO3 मतलब बिस्मथ फेराइट एक पर्वोस्काइट स्ट्रक्चर से संबंधित है. और हम इस पार्टिकल्स का यूज मेनली कहते हैं स्मार्ट विंडो, सेंसर, फोटोवोल्टिक्स एंड हाई परफॉर्मेंस बैटरी बनाने में यूज कर सकते हैं. और that's from my side. Thanks. Any question?
Yeah. It is mentioned that intensity versus degree graph. Can you explain that one?
Yes,
What exactly it was?
That is sir XRD diffraction. इसमें सर हम यह एक प्रोसेस है जिसमें कहते हैं सर हम हाई इंटेंसिटी को पार्टिकल्स में ये करते हैं मतलब उसको जिसमें सर हम हाई इंटेंसिटी लाइट को सर पार्टिकल्स के थ्रू भेजते हैं और उसमें सर डिफ्रैक्टेड जो लाइट्स होती हैं उनमें हम कहते हैं उनका कहते हैं इंटेंसिटी और एंगल ऑफ डिफ्रैक्शन देखते हैं जो कि हमें मिल चुका है सर 2 थीटा डिग्री और इंटेंसिटी का ग्राफ सर.
And what is mentioned in bracket at the top peak of that graph? Like 104, 110, what exactly it is? In the same graph?
104.
I mean, in the same graph, if you see on the.
Sir, that is the intensity peak, sir.
So 104 is what exactly? 012, 104.
012. Sir, I can't understand, sir. Please pardon me.
Can you see the X-ray studies, like the graph which you have shown? You haven't mentioned the figure number, so I am unable to recall it.
Sir, that is the intensity of the diffracted light, sir.
What is the unit for same?
Oh, sir, it means angstroms.
Okay, in the title you have mentioned that devices. So what kind of devices we can target for this material?
Sir, like a smart window जो automatically switch हो जाए, transparent to opaque and high performance battery, sir. जैसे कि हम लोग आजकल देख सकते हैं बैटरी की काफ़ी ज़्यादा शॉर्टेज होते जा रही है धीरे धीरे और प्राइसेस रेगुलरली हाई होते जा रहे हैं.
इनकी कैपेसिटी भी
कैपेसिटी लो है सर, तो हम उन कैपेसिटीज को बढ़ा सकते हैं विद द हेल्प ऑफ दिस मल्टीफेरिक मटेरियल. और सर जैसे कि सर हम इसे कहते हैं फोटोवोल्टिक्स में भी यूज कर सकते हैं सर.
ठीक है, ठीक है.
थैंक यू सो मच सर.
Thank you, sir.
Thank you, Anurag. So the next for the next presentation we have Khushbu Lalwani. Okay, Khushbu, you can start your presentation.
Hello, this is Khushbu from IIT Indore. Varuna. Varuna is a Sanskrit name for the god of water, and so our project Varuna is all about a smart groundwater monitoring system. Studies show that quality of groundwater changes even at a short distance of 500 meters and a slight change in the climatic conditions, which creates an urge to study the variations in the parameters of water. So we have designed a smart product to measure the water quality of groundwater. We firstly take the various sensors to measure the parameters of water like pH, temperature, EC, etc. and we connect them through an ADC with Raspberry Pi. Since Raspberry Pi does not have an inbuilt ADC, analog output of the sensors are needed to be converted to digital. Most of the power required for the sensors is given by Raspberry Pi, and so the only power needed to be supplied by the user is for the Raspberry Pi to work. Most of the models in the market are made on the Arduino board, but we have selected Raspberry Pi so that we could apply machine learning models onto the collected data. We have applied DNN on the collected data to calculate the water quality values and hence to accurately classify it into the 5 classes given by the World Health Organization. We have used GSM module so as to provide the internet to send the classified data onto a server. The problem in sending the data onto the free server is that anybody could access it. So we use an MQTT server. The MQTT server sends the encrypted data into the little packets. Further, a proper username and password will be set so that only the concerned people can access the information. Once the data is onto the web page, we can plot the real-time data to monitor the changes. From the cloud, the data is accessed through a mobile application. So the user will be able to access the data anytime and at any place in the world. The user will also get the full details about the water quality and also how to use this water and where this water will be best suitable for. We see that there is a lot of future scope of a gadget. The reason being that we can install many more sensors so as to get a much clear division about the water quality, like turbidity sensors, humidity sensors, etc. At present, we have already got 97% training accuracy in classifying the data. By increasing the parameters and by using a much more accurate model, we can increase this accuracy to even 99%. We can further add solar panels onto our system, and with a combination of batteries, we could give the power to the Raspberry Pi for working and thus save the electrical energy, laying the path for the green technology. We can make the product customizable depending upon the user requirement, making it user-friendly, super handy, portable, and cost-effective. Lastly, I would like to acknowledge IIT Indore for providing the hardware and technology, ASICSIN and Excel Dots for the invaluable guidance and time. Thank you. Any questions from the audience? Sir, if you please can show the second slide for the hardware, all the hardware diagrams are there on the second slide. So these are all the hardwares which we have used into our project.
Okay, yeah, Khushbu, as you said, the product is customizable. What exactly customizable you mean?
Sorry, the product is customizable. Yeah, so the product will be customizable in a way that we can ask the user like on which parameters exactly you want to measure. Like if that doesn't need pH for some reason, then we can remove the pH sensor and add the humidity sensors. And according to their wish, we can set the like what water quality and what the usage should be. So according to that, we can make the product customizable according to their needs.
And if you need to increase the sensor, so where maybe the changes comes in the product?
So if we have to increase the sensors, first of all, if they are the analog sensors, then we need to add the more sensors to the ADC channels. And if the sensor is digital, then we can directly connect to the Raspberry Pi. That it provides several GPIO pins for us to connect it with Raspberry Pi. So
Okay, so you are uploading the data from the prototype to the cloud. And if the internet connectivity not there, so is there any alternative things that can
we
be
have
incorporated?
used GSM module with the Raspberry Pi. So then GSM module's only work is to give the internet connection. So it is a 4G GSM module which will have a SIM geo SIM in it. So then it will give the internet connection. So we don't require an external internet connection for sending the data.
And for power?
For
How we
power
can give
also,
power
we
to
have
this
sorry.
Power, how we can give the power to this system?
We can give
I
power
mean, this would
directly through
have
like
the
electricity.
yeah, please.
Either directly connecting it to the electric switchboard, and we have seen that in future also we can use the solar panels and a combination of batteries so that we don't even need an electricity. It will directly work an independent system for giving the power to the Raspberry Pi for working.
Okay. Thanks.
Thank you, sir.
Thank you, Khushbu. Thank you. That was a nice presentation. So the next student with us, the next candidate with us is Mr. Natwar. Are you there?
Yes, ma'am.
Okay. So will you present your poster?
Yeah, I'm ready. If you can share, then.
Okay. Yes, it's there. You can start your presentation.
Okay.
Kindly try to finish it within 3 minutes.
Okay. A very good evening to all. So I am Natwar Botra, research scholar in IIT DAVV. The topic of my poster is effect of negative bias temperature instability on SRAM cell. So actually we are trying to observe the NBTI effects on SRAM cells, and I have taken 60 and 80 SRAM cells, and I have observed the effect of NBTI on various parameters of SRAM cell. So as we know, the scaling of technology has a severe impact on the reliability of semiconductor devices. So as we are decreasing the technology nodes, the NBTI effect plays a dominant factor in reliability degradation. So NBTI, it is negative bias temperature instability, occurred when PMOS is in the stress condition. So stress condition, that means if we apply 0 at the gate terminal of the PMOS, then it will be in the stress mode. So as we know, large area of system on chip is covered by static random access memory, that is SRAM, and due to that, the overall system performance greatly depends on the stability of SRAM cell. And as the stressed PMOS device in the SRAM cell will have the change in threshold voltage or the degradation in the threshold voltage of PMOS transistor due to NBTI effect. So the parameters of SRAM memory cell is also degraded. So the degradation observed in the drain current, in the right static noise margin, hold static noise margin, and in excess time. So we have analyzed the of NBTI aging on 60 and 80 SRAM cell with the stress time of 10 years. Now let me introduce what is NBTI. So actually, when a PMOS transistor is in the stress condition, that means when we applying 0 at the gate terminal, then due to the crystal defects at the SiO2 interface, the holes are trapped into the gate dielectric, which leads to increase in the threshold voltage VTH. And due to this, various device parameters of PMOS transistors are degraded, and ultimately they will make changes in the drain current, mobility, and transconductances. So we have observed these effects on 80, 60 and 80 standard SRAM cells. So as we can see, at a time, because at the output node we are storing 0 or 1, so at a time any one PMOS will always be in the stress condition, and that's why the threshold voltage of that PMOS will change, and due to that change in threshold voltage, various parameters will also be changed. So we have prepared a model to mitigate the NBTI effects on SRAM cells, and in that model we are observing the drain current or leakage current of the SRAM cell through NBTI sensor circuit. Now this NBTI sensor circuit is providing us the change in threshold voltage. We are actually using voltage converter. So this change in threshold voltage is compared with a reference voltage with the help of one comparator. Then this comparator will provide the change in the threshold voltage, whether it is lower or higher. Then the output of this comparator is provided to the compensation circuit. So with the help of this compensation circuit, we can compensate the change in the drain current, and ultimately this feedback path is provided to SRAM cell so that it can control the variation in the leakage current or drain current. So these are few results in which we have observed blue SNM that it write a static noise margin, hold a static noise margin, and read a static noise margin of 60 and 80 SRAM cell over a 10-year of stress period. And at the end, if I conclude this paper, then we can say the reliability is one of the crucial challenge for any circuit, and the degradation, it can cause the degradation in the performance with time. So we have to analyze this degradation, as well as we have to mitigate this effect of the NBTI on various SRAM cells. So we must have some mitigation system so that we can avoid this NBTI effect. There are few references. So that's all. Thank you to all.
Hello.
Yes.
Natwar, the question is
Yes.
from my side. Like if you see the top figure, that mitigation
Yes.
figure.
Yes, sir.
Yeah, it's invisible to me. Yeah, fine.
Yeah.
As we can see here, you have mentioned SRAM cell. So for every SRAM cell, the compensation circuit will be like this.
Sir, this is the idea which we are trying to work on. We are actually measuring the leakage current of SRAM cell through NBTI sensor. This green color shows
Yeah,
that I am working on
understood.
this SRAM NBTI sensor. Yes. Sir, you are
It will
not
be the
audible.
same, or for every cell it has to be a dedicated, that hardware has to be there.
Hello, sir, you are not audible to me. Please.
Hello, I am audible.
Yes,
Not?
yes, yes, yes,
Yeah,
sir.
my question is, now you have mentioned SRAM cell.
Yes,
So
sir.
let's say extended version of this diagram, maybe you need to have 1 kilobyte memories array is to be there.
Yes, sir.
And if 1 kilobyte memories array is there, then the rest part, as you mentioned here, NBTI sensor and the compensation circuit,
Yes,
that will
yes,
be
sir.
as it is, or there may be some changes with the size of array.
Sir, there might be some changes with the size of array, because right now we are observing a single SRAM cell. But if we are observing the complete SRAM, then obviously we need to make certain changes. Because in that case, we have to observe the reliability of all the SRAM cells. So obviously we will have some sensing circuits, some decoder circuits, so that we can address a particular SRAM cell.
Okay. Okay, thanks.
Yes. Okay. Thank you, sir.
Thank you, Natwar. So,
thank you.
So the next candidate for today is Pradeep Singh Jhala. So, is Pradeep in here? Hello, Pradeep, are you there? It seems he's not here, but we can start his presentation like he had shared a video. Okay. So would you please share the video, please? And rest of the candidate, if anybody is interested in sharing their video themselves, you can mention in the chat box.
Good morning to all. This paper shows the use of delta sigma modulator as a sensor in CMOS imaging chips. CMOS active pixel sensor have performance competitive with charge coupled device technology and offer advantage in on-chip functionalities, system power reduction. Charge coupled devices are at present the most widely used technology for implementing area image sensor. However, they suffer from low yields, consumes too much power, and are plagued with the SNR limitation due to the shifting and detection of analog charge packets, and the fact that data is communicated off-chip in analog form. This paper describes an area image sensor that can potentially circumvent the limitation of charge coupled devices and their alternatives. It uses a standard CMOS process and can therefore be manufactured with high yield. Digital circuitry for control and signal processing can be integrated with the sensor. Moreover, CMOS technology advances such as scaling extra layers of metal can be used to improve pixel density and sensor performance. So here is the picture of CMOS active pixel sensor. Delta sigma modulation can be used for sensing CMOS imaging chips that acquires image in camera or video recording. In figure 1 shows a schematic of CMOS active pixel sensor. Light is applied through a filter so that only red, green, or blue light passes to the photodiode. The photodiode changes the light intensity into a charge. The charge is converted into voltage and passed to the column line. The brighter the light, the bigger voltage change we get on the column line. The figure 3 shows some simulation results for the DSM circuit shown in figure 2. Notice in this figure that the resolution. The counter during these times can result in sensing errors.
Hello. Okay, it seems that's the end of the presentation, but as he has not joined, we cannot attend questions. Okay, so the next is Aman Sharma. So, Aman Sharma, are you there? Hello? Hello, Aman? Okay, no, he's also not there, but we can have his video. Like we'll quickly go through what he has shared with us in 1 or 2 minutes, then we'll go for the next candidate. Okay, it seems there is some network issue with our side. So from Neha Pandey, Rishabh, Aditya, who is there? Anybody's there in the attendee? Hello? Am I audible?
Yes, ma'am. I'm Neha Pandey. Am I audible?
Yes, Neha, you are audible.
Yes, ma'am. Can you share my poster?
Oh, hello?
Hello?
Yes, there is a network issue with our side. So
Okay.
Neha Pandey.
Yes,
Okay.
ma'am.
So
Yes, ma'am.
do you have your poster? Like you can present it?
Okay, ma'am.
There is some network issue with our side. We can't able to play the video. So if possible, you can present. Is it possible with your side? Yeah, okay.
I need some time because
Okay,
I
so
have joined from mobile and I don't have poster in it.
okay. So we'll try to share your poster. Okay, we are sharing your
Yes.
poster. So will you explain?
Yes, ma'am. I will.
Yeah, sure. Then we are sharing your poster.
Okay. Good evening, all. The title of my poster is Analytical modeling of 2DEG for in GaN, aluminum nitride and gallium nitride heterostructures. Am I audible? Am I audible?
It's audible.
Yes.
We present analytical model of 2DEG and surface barrier height for this heterostructure. Now first I will explain why we use quaternary compound semiconductor, because recently lots of work is going on ternary semiconductor, mainly on algane GaN based HAMT, because its application in high frequency and high power electronic device. In algane, if aluminum fraction increases, then it will increase the current carrying capability of device, but it causes the lattice mismatch between algane and GaN, and also causes electron scattering. And this scattering can be reduced by the introduction of aluminum nitride layer at algane GaN interface. And more research is going on quaternary alloy, because it resolves the problem of lattice mismatch. In this quaternary alloy, designer can adjust the lattice parameter by varying the composition of aluminum and indium. In our model, we have combined the advantage of quaternary semiconductor and aluminum nitride space layer. We have developed a theoretical model for 2DEG and surface barrier height. We have calculated polarization induced charge density. There are two types of polarization in heterostructure, that are piezoelectric and spontaneous polarization. Using interpolation model, we have calculated spontaneous polarization and piezoelectric polarization, and this combining this polarization charge density with already existing model, which is for GaN, algane and GaN heterostructure. We have find out the expression for NS and surface barrier height, and this NS and surface barrier height depend on, in our equations, it depend on thickness of layers and mole fraction of aluminum and indium, as shown in graph. First graph shows the effect of aluminum nitride thickness on sheet charge density, and next graph shows the effect of in GaN thickness on NS, and the third graph shows the aluminum mole fraction effect on NS, and the last graph shows the thickness aluminum in GaN thickness on surface barrier height. We have also compared our result with the experimental data available in the literature. They shows decent agreement. We can conclude it that we have developed a model for this type heterostructure, and also compare it with the practical result or experimental data which is available in literature. Thank you.
Thank you, Neha. Thank you for that presentation. Any questions? So any questions from the host? Okay.
Yeah, no question.
Okay. Thank you, Neha. Thank you for that presentation. So the next candidate with us is...
Thank you, ma'am.
Yes, thank you. So it seems he has not joined yet. So, Sir Rishabh, Professor Rishabh is going to join like in a while, but meanwhile, we can play the video for like 3 candidates who are not yet joined but like have shared their video. So for Aditya Srivastav, we can have the video for Aditya Srivastav.
Hello everyone, my name is Aditi Antriwale. I am here to give a brief introduction of our project. First of all, I would like to introduce my teammates. My teammates are Ankit Jain, Aditya Srivastav and Arun Rajak. Our project title is Wireless Security System. As we all know, security is one of the most important factors in today's scenario. As the world becomes integrated with technology, the security of people will begin and safety of the establishment. The alarming percentage of the security have triggered to create this project. As we all know, need of security is one of the basic necessity of an individual. But in this unsafe world, when crime, terror and threats are on their peak, how can a one attain the sense of security? And here comes the solution. Laser security system provides us a solution of all these problems. It has a wide application in the fields of security and defense. Owing to cost cutting and fast technological advancement, this form of system is becoming more affordable. This project deals with the model of laser security alarm system. Most home laser security consists of 2 parts. Number 1, a basic alarm unit, and number 2, an infrared motion detector. When any person crosses the path, it inhabits laser to read LDR, and the sensor generate a signal which reads the microcontroller to power on the buzzer. The main advantage of this project is it provides a constant protection, it provides crime detection, safety and security, and reliability. The applications of these projects are number 1, laser security system locks working. In this, a laser dome alarm is based on the interruption of a laser beam. The laser pointer is used as a source of light beam. Number 2, laser system. Laser technology products will calculate distance by measuring the time of flight of very short pulses of infrared light. Number 3, theft detection by a laser system. In this can be designed as a simple electronic project for demonstration in the science exhibition. It can also be made as a mini or major project for electrical and electronic students. When making this laser security system, one can know all about laser beam and their installations. While preparing a laser security system, we need to concentrate on the microcontroller program and installed with the laser beam devices. The main components of our projects are number 1, LED. It is a light emitting diode that emits visible light when an electric current passes through it. Number 2, buzzer. It's an electrical device that makes a buzzing noise and is used for signaling. Number 3, Node MCU. Node MCU is an open source platform based on ESP8266 which can connect objects and let data transfer using the Wi-Fi protocol. Number 3, PIR sensor. It is a passive infrared sensor. It is an electronic sensor that measures infrared light radiating from objects in this field of view. Number 3, LCD. A 16x2 LCD is meant to display 16 characters per line, and there are 2 such lines. Battery clip. It is used to connect the battery terminals. Battery, a container of one or more cells in which chemical energy is converted into electricity and used as a source of power. All these are the major components of our project. That's all about the project. Thank you.
Okay, so for the next, we have Mr. Rishabh with us. So, sir, are you going to share your screen or we will share it? Hello, am I audible to you? Okay, Neha ma'am, till then we can play your video too, so that like we can wait, but till now. Okay, it seems he joined. Hello, sir. Are you going to share your screen? Hello, Mr. Rishabh. It seems there is some network issue with its side. For the next poster presentation, we'll have Neha Maheshwari. So we'll have the video from her. Hello, Neha ma'am, are you going to explain your poster?
Yeah, please. Pratik.
Yeah, sure then. Okay, we'll be sharing your poster then. Okay.
Okay. Yeah. Am I audible? Hello? Hello? Hello?
Yes, Neha ma'am.
Yeah.
Yes.
Okay.
Yes.
Very good evening to all of you. I'm Neha Maheshwari, PhD scholar in Electrical Department from IIT Indore. Nowadays, challenges holds for the Internet of Things like secure connection of billions of low-cost devices is only possible if every device is capable of protecting sensitive data and secure communication. So I am choosing my topic like reliable and secure circuit design. And this protection is provided by certificates and cryptographic keys, similar to the passports in the previous example. However, so I am choosing like a technology that provide such security anchors are physical and clonable functions. PUF is a physical structure from which a device unique and unclonable cryptographic key is generated, and this key is used to protect the keys and certificates of the devices. Here, these are some quality matrices. I'm basically focused on uniqueness and reliability. Basically, uniqueness comes under the randomness. Randomness basically contain uniqueness, vitalizing, uniformity. Here, if we apply same challenge to the multiple puff circuits, physical and clonable circuits, then they will never produce the same outputs. Here, reliability is explained by if we're providing a same challenge to the same puff circuits over different time intervals. So we will never okay, we are generating the same responses all the time. So we can say the system is reliable. So I'm basically focused on SRAM puff. Here, deep submicron variation in the production process gives every transistor a slightly random electrical properties. And these transistors are basically used to design the SRAM puff. And when SRAM puff is powered on this randomness is expressed in the startup values of zeros and one of the SRAM cell. The startup value create a highly random and repeatable pattern that is unique to the each chip. And these random patterns can be again reframed into the cryptographic secret keys. And this can be used as a perf circuit of security keys. Now, these are some stability parameters. Here we are classifying it as technology parameters and non-technology parameters. Technology parameters basically deals with the dimensions like length, oxide thickness, width, channel length modulation, which comes under Bion oscillation of the MOS operation. Then threshold voltage basically depends on doping concentration and oxide thickness. And some non-technology parameters are supply voltage and temperatures. Here I have discussed some non-technology parameters here. If we apply the reverse bias voltage to the PMOS transistor of the SRAM, so in this case, the threshold voltage is increases. So device turn on slow. So leakage current is decreases, corresponding stability is increases. If we consider the effect of temperature, if we want to overcome the effect of temperature, then we will apply the substrate voltage in the reverse bias to the puff circuit inside the SRAM. Okay. Here, these are the applications of the SRAM as device authentication for using puff and cryptographic key generation. And at last, the conclusion, the SRAM puff-based device security is proven to be a reliable method to store the cryptographic key for long period of time under wide varieties of circumstances. And it basically, if we want to increase some more reliability issues like temperature variation and supply voltage fluctuations, then we can generate some error correction techniques inside it to make system to be more reliable. These are some references. Thank you.
Thank you, ma'am. Thank you for the presentation.
Yeah,
Any
no
questions?
question.
Okay. So moving to the next participant. So it is Rishabh sir. Is he here? It seems he left the meeting. Okay, Mr. Rishabh, we'll be sharing your video. Meanwhile, you can have further questions if there will be any.
Hello, myself Rishabh Barjatya, and I'm going to present my poster on a self-cascode approach-based QVCO for 5G application. Myself Rishabh Barjatya from Prestige Institute of Engineering Management and Research from Electronics and Communication Engineering Department. My abstract is that I have designed a QVCO using self-cascode technique for 5G technology. Self-cascode structure actually it provides a very high output impedance, and it consists of one transistor above another in stack form. So in this design, I have placed two PMOS transistor at the top and two NMOS transistor at the bottom. And minus 4.370 hertz and offset hertz, which is better than previous. And frequency for is 3.6 gigahertz, which provides a tuning range of around 3.75 gigahertz to 2.92 gigahertz, and voltage is 0 to 1.2 volt. Whole circuit consumes around 6.78 milliwatt of power, and it is designed at 65 nanometer technology using 1080 the basic reason behind designing this QVC is that because the technology is increasing day by day, and we are in the 4G generation. It is adopted, and now it's a generation 5G, which is going to be future. It is also a 10 good option for mobile and smart home, Internet of Things. And many other countries are also showing interest in 5G technology like Europe, US, Asia Pacific, Taiwan. Taiwan, they are planning to launch 3.4 to 3.8 gigahertz, 4.4 to 4.9 gigahertz, 28 gigahertz, and 700 megahertz, and several other frequency bands. So the 5G technology is also better because of simplicity, low power consumption, and unnecessary of expensive and large chip area filters. The block diagram for a transceiver is this. Might be not possible to view this photo. So I explain myself, such as it is consists of a filter, LNA, mixer, and QVCU. So I have designed a QVCU, so I will focus on QVCU only. In this, the frequency from LNA and QVCU gets mixed and depend upon the application frequencies of convert or down convert. So what is the basic function of a QVCO is to generate a 4 oscillation at different phases. And the parameter on the basis of QVCOs are designed are tuning range, voltage tuning range, power consumption, phase noise, figure of merit, and supply voltage. Generally, QVCO is of two type, ring and LCVCO, but I have opted for LCVCO because this provides a better and temperature output with lesser filtering, jitter filtering. So what I have done is I have shown in methodology that I have placed two transistors, PMOS transistor near VDD, this one, and I have kept two NMOS transistor near ground, this one and this one. So what I have achieved is better phase noise as compared to previous work. This type of arrangement helps to increase the output resistance and better output impedance. And they are connected in stack form, one above another. These two transistors are in stack form. Stack form, these are in stack form, these are in stack form. And these are the LC circuit 1 and 2. So all this whole circuit generates 4 output at different phases. And I have applied a tuning voltage from 0 volt to 1 volt. With the help of this arrangement, I have achieved this transient response of QVCO. It is generating a 4-phase output, different phase, and I have also achieved a phase noise of around minus 124.37 dBc per hertz at an offset of 1 megahertz. The tuning range around 2.9 to 3.75 gigahertz with tuning voltage of 0 to 1.2 volt. Okay, so frequency range of this QVC is 0.83 gigahertz. Okay, and I have also compared my work with other references also. So here are the comparison with the other papers. I've used 65 nanometer technology and center frequency I have kept is around 63.6 gigahertz. VDD is around 1.2 volt, and I have achieved a tuning range of 830 megahertz. Phase noise is around minus 124.37 dBc per hertz, and figure of merit I have achieved is minus 1 dBc per hertz. So what I conclude is that if I use a cascode fashion cascode technique in designing QVCO, then I will get phase noise, good phase noise. I have phase noise 4.03% than previous one, and so I have used a range design.
It seems he left the presentation for questions. So that's all for the poster presentations for today. Thank you everybody for joining, and good evening. Bye. Next sessions will be of tomorrow morning 10 to 5.
Thank you.